They completely banked on Plasma Desktop plus the small utilities coming with it. And then they have a few critical applications for them, KWin, Ocular, Inkscape, LibreOffice, Firefox, fighting for dominance with Google Chrome like everywhere else, I guess. Console. You might think that they use console only on the IT department, but interestingly, they use it in other departments as well, because their ERP, the ERP that they use, there's interesting functionalities which are provided only via terminal use. So yeah, you get your office clerk doing some things in console there. So that's for the desktop, right? And then most of the rest, that's enterprise desktop, right? Most of the rest has been moved to web applications. For that, that's a mix of on-site servers and cloud use. And you get like a bigger mix of free and proprietary software there. They have a couple, so the yellow ones, that's a couple of software that they made in-house for their own use. And obviously, I couldn't fit everything that they have, right? They have much larger offering there. The last block on the right, that's the supporting services on which everything else is provided. So for instance, they provide remote desktop access for the remote workers, for instance, LDAP server, and the file sharing is mostly through Samba, but there's currently a move slightly in popularity. People are using a bit more and more Google Drive there. So they decided to have this kind of organization, like, as I said, 20 years ago. They figured back then that the web apps would basically start to eat everything. I got a nice quote from them, which is basically, in summary, the rise of the browser, that's what cemented the case for the Linux desktop, right? If there was not that move, then they would probably be more dependent on business-specific applications, which would be on Windows. But since everything of that moved on the web space, then it's much easier to actually say, well, let's move everything to Plasma, right? So we did a bunch of things with them. First, we got in touch a little while ago now. We actually spotted like an email on the KDE mailing list, and there were people with problems. And no one could do that on their own at the time. So we simply reached out and said, okay, what's exactly the problem? Could you help us figure that out? And we've seen if we could do that through paid work. Nothing came out of that quite immediately, but we kept the communication open for over a year. And then they had a real blocker. They were like, yeah, okay, this one, you really need to help us there. And so that did with some PDF rendering in Ocular. So that's a funny case as well, because while they're making wines, and so wine bottles, and there's labels on the bottles, right? So they have to deal with reprographics companies, and so they have a very extensive use of PDF and some features that you don't generally use in PDFs. And especially the overprinting preview was completely missing in Ocular, and they wanted to get rid of Acrobat Reader for Linux. So they kept around for that, so we had to fix that. We also figured out that there were some more cases of Ocular failing some of the PDF test suites that you find around there, so one of those has been fixed as well. I'm not getting in the details for time reasons, mostly. With the spread and their use of Samba, they use CIFS mounts on Linux quite extensively. And so obviously they find issues. So again, we figured that there was no chance to properly save changed files when they were on CIFS mounts. That required fixing KIO. KIO, again, they had problems with the directory listing for the file dialog that we addressed with some heuristics and aggressive caching. And then they started to throw us in different directions. So closer to LibreOffice, where there were issues during saves as well. And we actually carried that one all the way to the kernel and figured out that was actually a problem in the CIFS driver on the kernel. We took the opportunity to actually go, okay, you've been using our stuff for 20 years, right? What do you think of it? So they're very loyal, right? The good for them is KDE4. For them, the switch to KDE4, that's been a major shift in the way KDE saw itself and how they perceived KDE. So from them, that was like moving from hobbyist to actually professional project. They actually even mentioned Aaron Saigo as instrumental for this change of perception. They like the fact we maintain a standard desktop windowing interface paradigm. They think it's cool that other communities experiment maybe more and so on. But for the enterprise desktop, they need that, right? Because they need their user to have something stable and known. And they like the overall responsiveness and developer access, which is generally very good, well, depending on the volunteer time, obviously. The good thing, not much, they said, but if you push a bit, you learn a few things. They found out, because they use authenticated proxies, that the KDE Community services, like getting the Plasma themes or this kind of stuff when you talk to the store, that apparently doesn't work well or at all. They think that maybe the web-first support could be a bit better, especially if you think about this kind of shift. There is a bit which has been synced locally and then open it directly in Google Docs, right? And it's a bit clumsy right now to do that. And obviously, they thought that finding professional development support wasn't easy, and so they were actually happy to find us, right? I got a nice quote for the whole community, so you can praise all yourself for that. So from their project manager, who said that he's been participating in many communities over the years, and for him, I mean, we're basically a shining beacon of doing things right? Balancing the growth, the innovation, the health management, and that's not something easy, so yay us, right? As a conclusion, As a conclusion, we learned a few things. I'm kind of extrapolating from a single case here, but I see other enterprise stop use. So we can make a few informed guesses. We make a fine enterprise desktop already, which is good. Even better if we go a bit further in embracing the web applications case. And if it was easier or clearer, I don't know, to get the professional support that people are looking for. We successfully tried a contract model with them. That's probably something which won't scale, so we can do that because that's one's customer, but if we want to handle more of them, we probably would have to be a bit more creative there. That might require gauging the market a bit to find the right approach to actually handle that. And which means we might want to do a survey or something like this to get better information about the enterprise use cases for the existing users, right? Because that's one, but there's probably more we can learn from to figure out their needs. This is a very short talk. I couldn't get into the hardcore technical details. You can trust me, that was very fun. There will be a post on my blog sometime next week with all the gritty details if you want that. And thanks for your attention.
Thank you, KWin.
How do I do it?
Yeah, you do that yourself.
So next up,
And then you get to do this bit. Oh.
Yeah.
David Edwardson will talk to us about the next generation of KWin effects, if he got his microphone ready. Do you want the clicky thing?
Ta-da.
Congrats.
Okay. Wait, need to summarize how KWin draws at the moment. So KWin is responsible for drawing your windows on the screen, and then occasionally we draw effects on top. And the way it currently works is there's a simple path to draw all your windows, and then throughout this, effects have various hooks where you just randomly throw OpenGL calls in the middle of KWin trying to do its main business. And OpenGL code's quite long and old, so this is code to draw a circle. Not lots of circles, a circle. Don't expect you to read it, it's a lot of code. And I wrote this slide without knowing Martin was going to be here. The result isn't very good. It looks like it was written 10 years ago. Fair enough, it was. But the problem is, the Quin developers, the core developers, want to make the core even lower. They really need a fine-grained control of everything we're doing, chaining which OpenGL call based on which drive you're using, what day of the week it is, and drawing onto different planes, and having absolute control of everything, knowing how long everything's going to take. And they want to have this really light scene graph with very simple rectangles, and long-term, also have a path to Vulkan. And I say long-term, there's work in progress right now. And you can't have a path to Vulkan if you have loads of code throwing OpenGL calls at your screen. Now, as a not hardcore dev, that's not what I want. I want a very lightweight, simple API where I can draw in, load an image, load a texture, draw some text, which is really difficult in low-level OpenGL. And I definitely do not want to write another path for Vulkan. It would mean rewriting everything from scratch. So if we're going to do that, we need to look for a path forward that satisfies both of those sets of requirements, which are quite competing. So the solution is to have two solutions. The low-level Quin goes lower, and the high-level Quin, where we need effects, goes higher, making use of KWin. So your KWin code renders into a texture, into an off-screen buffer, which the low-level code just sees as a rectangle, doesn't care what it is. And if the high-level code wants to render a window or a whole desktop, it just sees a regular KWin item and doesn't care where that content's come from. And the main change was making all this happen really, really fast. With shared OpenGL context, we can make all of that happen. So the benefits. We saw that 20 lines of code to draw a rectangle. KWin, really easy. And also, the designers can come in along. People who don't know any C++ can come in along and add a color, which actually I've forgotten. But it's really readable code. It's really to edit, maintain, which is what we want. And we get features like anti-aliasing for free. So it looks like a nice circle, Martin. Sorry. But we also get interactivity really easy. So we had this overview effect in the past where it zoomed out and you saw all your windows. But doing a drag and clicking a window and dragging it into another desktop, that was a lot of painful code. And sometimes we didn't have all of this code, where you can start searching and get KWin results. And that's really easy. All sorts of drag and drop and sliding and swiping. Not very difficult code now. And KWin 3D is amazing. And it's relatively easy to use. So we added a cube back, obviously, because everybody loves a cube. But I'll go for an example. We had that effect before where you click a mouse and you get a little circle. Why not a full 3D hand? And before I exported this to a PDF, this was a lot more exciting. So could you just pretend this is whizzing around with a vector animation on Euler rotation? Just imagine that. But it's not even very difficult code with KWin. You get a model, you run this magic command called Balsam, and then you've got your model, and you can just throw it in there. And you've even got all sorts of things for 3D. And obviously, we should throw more particles at things, because particles are awesome, especially 3D particles. So we want to rewrite a lot of our effects, and that opens up to everybody. If you see any Quin effect code that is doing drawing, which is the part we want to really move over to KWin, grab it. It's quite a good task to get involved in Quin if you're interested. Or do cool stuff with 3D and particles. But get involved. That's the end. Yeah, it's lunchtime next. I'm not going to keep you.
Talk for 5 minutes more. You have the time. Any quick questions? Yes, one. OK, let's go for it.
For those on camera,
let's
Martin
give
is
the
asking
people time to
questions.
prepare lunch.
Not really a question, but just a comment. So declarative QML effects is something I dreamed about something like 10 years ago, and I had concept of how to do it, but the technology was just not there. So I really love it.
Okay, we have another quick one, please.
Is this on?
Yep.
I just wanted to mention something you didn't mention in your slide, but for the current C++ effects, a lot of them also have a software path. So this is really nice. Instead of the separate OpenGL and software path, now it can all be through Qt Quick.
That's right,
that's
yeah.
quite a bit of complexity we could get rid of.
Yeah, so we've currently got 2 paths. It was going to go up to 3. Now we've gone down to 1.
Good. Thank you, David. Thank you, everyone. Lunch is downstairs. There's an optional donation of 10 euros. Find the person with the unicorn bag if you want to donate. And I think we start again at 2:30. So enjoy your lunch.
hints to tooling. The runtime didn't actually do anything with those type annotations. Since 6.7, they are actually enforced. So if you now pass a string into this add function, the string is the JavaScript coerced to int. You'll be delighted. But I had basically no other choice than using the JavaScript type coercions there. So that's what it is. And yeah, why do we use them? As I mentioned before, so that like you yourself and anybody else who reads the code later can grasp what was the intention of the code, and that the tooling can make sense of it and compile it to C++. And of course, you can also use var if you don't actually know the type, but you should sparingly. Related to that, we also have type assertions now. They've also been around since 5.15, and it was an interesting ride. In 5.15, they didn't do anything at runtime. Like if you passed a type to this as here, for example, with the font, that was not a font but a rect, it would just go on and like try the family property from rect, which doesn't work in this case, but let's say you have rect and point, and you take out the x property, and it would just work, besides not being the right type. So since 6.2, they are actually checked for object types at least. So a second example with the getX, if you pass something else than an item into this function, the as expression will evaluate to null, and that will result in a JavaScript expression, no matter if the type that you have there has a property x or not. And since 6.6, we also do things with them if the right-hand side is value type. And as somebody has pointed out to me, those were some horribly wrong things, because as you know, we have JavaScript type coercion. We should use JavaScript type coercion there, right? So if we can construct a font from whatever you've passed there, we should construct a font, right? Well, no, but luckily it never worked. Like most of the time it didn't work because it accidentally fell back to the object type coercion produced null, which it also shouldn't do. But that's not so bad because null is close enough to undefined, which it should actually return there. And so since 6.8, we got that right, but we couldn't straight out fix it because of backward compatibility. Therefore, if you're going to use type assertions for value types, use this nice pragma there and avoid any surprises. And then we have generalized group properties. Generalized group properties is quite a mouthful. And as mentioned, you don't actually have to know what it is unless you want to implement some yourself. Most prominently, we use this to fix property changes. If you look at the first property changes we have there, there is a property, a binding on opacity in there. Now, the type property changes, as far as I know, does not have a property opacity, does it? So the KWin would say, no, you cannot compile this. What is that? But you don't have a property opacity there. And the way it works at runtime is there's a custom parser that cannot the compiled bytecode of that property changes, but run the source code at the AST, and like runs to the AST and fixes this to like not point to the property change itself, but to the target you've specified. But that's all custom code hidden inside the property changes implementation. And so what we could run in the compiler is like special case property changes, and then special case connections and binding and state changes and anchor changes. And no, I wasn't going to go there. And so we came up with something else. And that is generalized group properties, which we can use in all those places. And generalized group properties is a construct where we have on the left-hand side an ID, and then a property on that, and you can install a binding on the result, and that is typed. Because now we know the left-hand side here is an ID, root. Okay, we can look up that ID, and the QML Cachecin knows that ahead of time already. And then we look at that and see opacity. Oh yeah, there's an item, it has opacity. And we know what that is, it's double, and so we can install a binding on that, and that just works. So we have that now in binding and in property changes, and works nice, and it's not only easier for tooling, but it's also nicer to read, in my opinion, and simplifies the syntax some. And yeah, we haven't done it anywhere else because the other cases weren't so widespread and so bad, but it should be generalized to the others too. On the other hand, there's a related concept in connections. In connections, we don't generally want to do that, or sometimes we want to do that. But generally, we don't want to do that because if you have a connections element, the most common thing is you don't actually know the target in advance. You can reassign the target. So an ID wouldn't do there. And as you can see in the first example with connections here, that's basically the same thing. There's an on-exchanged signal handler here, and yeah, connections does not have a signal changed. That does not exist. And what we did there is a mechanism that loosely couples a member in the connections element that you define, that you newly define to some functionality that's behind it. But the member we defined there, that function on YChain, is valid already in like plain QML. You don't need a custom parser for that. And the connections element then goes through its functions and checks, oh, is there something that looks like a signal handler and that matches my target, and it attaches that. And that is basically the other side. Either you know the like element you're referring to in advance, then you can use generalized group properties, or you don't, then you can use a tag like that. And that basically is so far only implemented in connections, but we have to do the same thing for binding and property changes, etc. too. But in connections, again, that was the worst thing because everybody uses connections. So I'm happy we have got it in there. And then another thing you can do in QML these days is named value types. Now I do have a little bit of C++ code here because this is a relatively unknown thing so far. So from C++, you can register types that are not Q objects these days. And you can give them your own names. So you see this wrapped int type here. And with this QML value type macro, you can tell the tooling, OK, this is a value type called lowercase wrapped int. Value types have to have lowercase names for various reasons. Don't give them uppercase names, or it will slap you around. And then you can use that like font or rect or all the other value types we already have built into QtQML and QtQuick. So for example, you can assign things to, or you can read out a member here. And then on top of that, since 6.5, you can also have value types you can construct. For that, we have an extra macro, QML constructible value, and you have to make the constructor Qinvisible. And then tooling and the engine will figure out, oh yeah, I can call this constructor. It has to be a constructor of one argument. And then basically, if you have the right kind of type on a binding on it, it will automatically construct the value type.
Why do you need the constructible value if you do have the constructor?
Yeah, because I didn't want to make that automatic, because people might have constructors on their random types around the place, and then you want QML to either like make, if that's actually wanted, the automatic conversion, to do the conversion, or to warn about it if you do this like assign it into it magic in QML, right? Because otherwise that's quite magic. So I wanted to make it explicit. And on top of that, you can also have structured value types these days. Structured value types work kind of like constructible value types, but you can also construct them from a JavaScript object where just all the properties are assigned one by one from the members of the JavaScript object. And it doesn't have like a JavaScript object literal. It can be anything that looks like an object in JavaScript. So it can be another value type instance. It can be an object type. It can even be an array. The only thing it needs to have is some kind of properties that can be extracted to populate the other type. So this is like, again, somewhat dangerous. And that's why I made it a separate macro too. Yes?
On the value types, for example, this property I, is that notifiable? Can I bind to it?
Value types cannot have signals. But each value type is a member of some object via some path of other value types. And so the QML runtime simulates notifiability via notifying on the like outermost property that's a property of an object type. So yes, you can have like on iChange there. It works. It's a bit complicated and a bit expensive, but it's not so bad.
You can change block to do that.
To do what?
To need a signal.
Yeah, but if you need identity, so in order to connect the signal to something, you need like an identity on the left side, and that needs to be like stable. But if you have value type, and that's assigned to some like recursively to some property, and change like whatever that is, it might get reallocated, and yes, so that's why it doesn't work. Now, container types. Container types are funny in QML. As a historical artifact, we have too many of them. We have JavaScript arrays. That's because we need to build a JavaScript. We have various other JavaScript things that look like arrays. I'm going to ignore those for now, but they generally have the same API as JavaScript arrays, so it's not so bad. And then we have our QML list types. There's QML list property that in Qt 5 worked quite different. And there is various lists, Q lists, and standard vectors that are manually exposed, or were manually exposed to Q and special case in various interesting ways. And some of them had a similar API to JavaScript array, and some had some random craft, and QObject list was special, and QVariant list was special, and oh no. And it was like, yeah, I was getting lots of bugs because why can I use push on this container, but if I use push on that container, then this happens? And so I went and fixed it. So, JS array is the reference here. Like everything should, because we are basically locked into JavaScript, everything should have the same API as JavaScript array, right? And that's what I did. 6.5. Everything that looks like an array works like an array. Yay! And most of the special casing is gone. You automatically get the right types registered. If you register an object type, you get QQML list property of that object type for free. And if you register a value type, you get QList of that value type. And since 6.0, you can also do the thing we used to do in 5 with standard vector int and standard vector bool and whatnot. You can do that yourself. There's a macro called QML sequential container, and that will just expose the type to QML the way all those containers are exposed. And That latter thing can only expose anonymous containers, so you cannot define properties of that. But if some C++ type has a property of that or returns something like that from a method or accepts something like that as argument to a method, you can pass it through and you can treat it like an array in QML. And then I thought, yeah, we have lots of interesting things as models for various views. Like we have a list model thing with interesting custom parser on list element that I don't quite know what to do with yet. And then we have abstract item model that can be passed through there, and like plain integers and various things. And you'd expect that any kind of list-like thing would work there. But in Qt 5, not everything worked there. Only special things worked. And so after fixing all the list inconsistencies, I went and fixed the model data too. So anything that looks like a JavaScript array, anything list-like, can use as a model to all our views now. So for example, here we have a list of size, the size value type, as a model to a repeater. And then you can have a required property width, and that just works. And then, yes?
If I can use now lists as models, if I then change a single value in that list, will I have a complete model reset?
Yes. Yes, in general, yes, because you're with QQML list property, you don't have to reassign the whole list. But you but that won't work. You still have to signal the change somehow, and you can only signal the change for the whole list, and so too bad. Yes?
Does delegate chooser, does it work on this list?
Yeah, delegate chooser is one step removed from this machinery, so it should work, unless there's a bug somewhere. I haven't checked, but. Oh, that's interesting. Can you write me a bug report for that, please? Okay. Thank you. Yeah, and then the other thing I recognized is you can now have required optional properties, as contradictional as that sounds. But you can see that here. We can say, okay, we have a required property rect model data. Model data is a thing that captures the whole model data passed to the delegate. And since rect is a structured value type, it gets populated property by property. And rect happens to have properties width and height. So what you get there is a bunch of rects that are always at the 0, point. And have a certain width and height as specified by the size. So that's a pretty neat thing, and it just came for free. Now, having done all of that, there's a lot of other stuff still left to do. One thing to do about the whole type-safe machinery is we need some way to express function types, so like some callables basically, because that's what people struggle with mostly right now. You have like several different types that all have some function in common, and you have a QML interface that takes one, or a QML property that takes one of those types, and you want to call the common function on that, duck typing, basically. And in order to resolve that, we need some kind of like function type you can put on the right-hand side of a type assertion, so that you can still type safely call any of those functions. That's pretty high on the list. And the same thing, some types. Basically the same thing. You have like one of those types, and my property might carry any of those, but only like those 3. not more than that. And that's also to resolve duck typing, very common thing in QML. And then we have like those value types and list types have a drawback, as noticed just here a minute ago. You were assigned to them, you like have to assign the whole thing. And for lists, unfortunately, that means you have to copy the whole list. And you don't want to do that all the time. So I'm thinking about like having a extra attribute to q_property that gives an internal pointer to the things so that we don't have to always change or always like copy the whole thing in order to update it. And that especially helps with like recursive data structure where you have a list of value types that themselves have other value types as members, etc. You can probably imagine how terrible that is if you then update some member integer I in the innermost instance of that. So don't do that yet. Use it for simple things. And yeah, as mentioned before, another thing we need to do is finish generalized group properties and loose coupling to cover all the various elements we have there and not only the worst ones. And once we get to like fixed binding that way, we can also put in support for bidirectional bindings, since that seems to be a very commonly feature. And then, so far, value types can only be defined in C++, as you have seen there. It would, of course, be very nice if you can also define them in QML, like you can do with object types. And those are the things that I'm pretty sure about how to do. Then, what is next is like things people have complained about, especially like KDE people, and and I'm not sure about how to fix that. But one of those is context properties. Yeah, we own context properties. Like kind of nice because you just mesh some object into the like root context of the edge that shows up everywhere, and it's so easy. Yeah, great. But QML Cashcat doesn't see it, and QML lint doesn't see it. And QMLLS doesn't see it because you've hidden it somewhere in your main CPP inside an inner loop of 13 like depth. Yeah. So that needs some fix. I don't know how to do it yet, but it needs some fixing. And another thing I don't quite know yet is writing model data from delegates. So if you look at the example with unification of model data here, yeah, you can have a type model data in your delegate, but that's a property of the delegate. And if you write to it, well, you write to it that you have a different value in your delegate, but it doesn't propagate back to the model. And so far, you can write back to the model by like looking up the model and writing into it, right? But it would, of course, be nice if you could do directly from the delegate. If the delegate could just write to some representation of its piece of data, and that would propagate back to the model. That is so far not doable in a type-safe way. And finally, you may have noticed in my example with, where did I put that? Here, that I had to put font, or rather KWin into this type namespace QQ. And does anybody know why I did that? Yeah?
I mean, you told me maybe a couple of days ago, so it doesn't conflict with some variables and you can address the type?
Yes, to make the type font addressable here, because value types are by default not addressable. And for a reason, because if they were addressable, they would shadow properties. And value types, as well as properties, are lowercase, so that would be like disastrous. And therefore, I have to like put it in a type namespace so that I don't have to look it up unqualified, and as qualified thing of the type namespace, it works. But that is inconvenient. Who? Oh, yeah. And so one thing to do about that is just redesign the lookup hierarchy so that the types are on top of it, but somewhere like further down below the properties. That is not as simple as it sounds, because between the types and the things further down are all the contexts and all the scopes all the way out to the root context of the engine, and we have to thread it in somewhere in there. Yeah, I don't have a solution for that yet, but it needs a solution. Yeah, and that's basically what I wanted to say here. And now I hear we have 10 minutes for questions. Yes? Oh.
One thing I've noticed clients do is they often want to use models within the QML space, and sometimes those models are rather complex. They want them to contain nested data, and I haven't found a good way to do that and still have it be somewhat optimized by the QML compiler. Any inputs on that?
Yeah, one way you can do that is write your own abstract item model, of course. And you put in anything there, and you can return a Q object as some piece of data somewhere, and have another model in there. That gives you the full flexibility.
All right.
And another thing you can do is like use the new support for lists with some care to not like copy the list too often. And what I've shown there with lists of value types also works with lists of object types. So that might help, or with lists of JavaScript objects, but don't do that.
All right, sounds good, thank you.
Yes?
Okay, two questions. The first one is about the type annotations. I know type annotations are like awesome, but if you need mocks in testing, that's going to be a problem because, for example, you need an object of type of a specific type that maybe that does network I/O. But in testing, you don't want to actually invoke the network I/O, so you use a like a mock type instead. Then if you annotate the type to be the concrete type, you won't be able to use the mock type in testing, right?
There is a fairly blunt way to work around that. And that would be have a different QML module that exposes this like network type for your testing that you have in real in production. So basically write a second QML module that has a different network interaction type that's just mock, and then test with that in the import path. And when you ship for production, you replace it with the actual module.
Okay. And another thing is about the lifetime of Q objects. As a JavaScript programmer, I feel it's really confusing and sometimes surprising when some things that got passed into the function can just become new at any time. Like even a URL list from a drop event, it can go become new at the next tick of the event loop. Is there any plan to, say, work around this?
What do you mean with become new?
Like, so it's a URL list from a drop event, and say we want to extract the first URL and the second URL in like whenever the user clicks a button.
Yeah.
And when the user clicks the first button, the URL list is there. And then it disappeared.
Because it was an argument to some event handler, and no, how does it disappear?
This is like the URL list comes from a drop event.
Yeah.
Yeah,
that
that goes past.
Yeah, that is an argument to some method or some.
And like I passed it, like I passed the URL list into another function.
Yeah.
And I say display the file name when the user has clicked a button, and when I guess maybe the event got destroyed.
Well, in general JavaScript, whenever you hold on to something somewhere,
Yes.
it should not be garbage collected, because that's the whole point of the garbage collector, that it marks things that are still in use. It does not collect them. So if you found an instance where something got collected, but you're still holding a reference to it somewhere, then that's a bug. Then you should write me another bug report.
Wait, this is pretty common across my QML experience, because if it's like a Q object, it got destroyed when their parent is destroyed.
And it was a property of a Q object you have there. Well, oh.
Yeah, it is a property.
Well, we have to look at that in more detail. Maybe you can show me the code, and then I can see what it does.
So I have two questions. One is, why is it not going via the new operator, like using us to create things with it? And the other one is, are there any plans to like integrate those value types with like type conversions? So like I can have a type, and then if I pass it into a function which expects a string, I get the string. Or if I use it as a number, and I can do calculations. Like think of a I don't know, coffee recipe or a value where you have like 5 liters, and on C++ you make like structs and std, and has like std kilo and whatnot. But in representing that in QML is very hard, because QML has no idea what this struct is. It can do to string, but you can't really do any maths and numbering and stuff with it easily.
So first question, why do we not use new creating value types? Well, we do, but I'm not telling you right now, because it might be an idea. I might remove it again. And second question, besides toString, there's also value of in JavaScript. We don't support that yet as invocable function, but that would be the way to convert to numbers. Cool. And I kind of have it on my radar to do that sometime, but yeah, I have a lot of stuff to do.
Thank you.
Okay, I guess time's up.
Microphone.
Yeah, it seems to work.
Oh, what?
I had the same issue. I wasn't like marked as a speaker or something, so there's no edit.
Okay, thank you.
I emailed it to Karen, but
Okay.
I mean, anybody who has admin access to it should work. You don't have your own laptop to use.
Pardon?
Why don't you use it? Oh, because
Oh. I'll upload the slides afterwards. How important can it be?
Well, the problem is that people on stream can't look them.
Oh, okay, right.
That's why.
Okay.
Let me know when you're ready.
Okay, hold on. I've been told to email things. That's not right, Kieran. Yes, I've been told to email upload my slides to Indico, but I can't. No.
Then don't.
Okay, fair enough.
So you have to put that in
Oh, sorry.
your pocket.
Oh, sorry. I'll hide behind here, and then I can.
Allow me to introduce Mr. David Edmondson, who will be talking to us about adapt or die.
Yes, I want to talk about what packaging format changes mean for the wider KDE. And by packaging formats, I mean Flatpak, Snaps, Linglong, and I don't know enough about them to say which one's better or have that discussion. I might have a favorite. I'll point to it. But the point is they are also than the current state. And for the purposes of this sort of talk, they're all the same, and they're all similar, where you have a runtime provided by KDE, which has a bunch of libraries, and then the application takes a version of our runtime, and it's all put in a nice little box where there's a few ways to talk to your host environment, but not a lot of ways to destroy your system. And it's amazing. They're all amazing, and I've not been doing a lot of this work on the Flatpaks and the Snaps, but I wanted to share my moment of enlightenment of when I realized it's not just another way to get apps, but how we should be approaching things as the default state that we should be aiming for, the future. And talk about how this affects some things we do in frameworks, how it affects some things we do in Plasma, and really focus on where we go from there. So, my moment. As a Wayland developer, I have to pick up random projects and see why I work under KWin, which is normally the application's fault. So I had to build some random GTK application, and I tried building it, and it requires a newer version of this thing, an older version of that other thing, and trying to find this Goldilocks situation which compiles was a nightmare. And I wasted a day on whatever it was. And then I double-clicked on the file, and GNOME Builder opened up. And it had all of the source code for your project. It had all of the source code for your dependency I was actually wanting to change in the library tree. And all of the other dependencies got magically brought in. And it was an amazing developer experience. And my takeaway from this was, that was nice, but I don't need it in KDE because I already have a dev setup. And I think everyone in this room probably goes, we don't need any of that nice stuff for getting all your dependencies because I already have all your dependencies. And when you say it out loud, you realize that's not a good way to think. So using this as a way to get people on and have other people quickly build your app is really important. If you go to most GNOME now, like a new GNOME terminal that's just landed, the README doesn't say clone this repo and get these dependencies and store these headers. It says clone this repo, open a Flatpak file. And I think we want that experience in KDE. But if you look at any of our READMEs, our README for Ocular just says clone this repo and hope your distribution's got the right version of these things and do your weird things you need to do under Debian headers, which are missing, and go through that painful process. So that really changed my mind in thinking, this is what we need to be doing. The other thing that happened around the same time as the call for papers was we had an issue in Plasma where somebody randomly grabbed something off our store, and it sort of wiped all of their files. Yeah, a little bit wiped all their files. And we've got simultaneous extreme situations where we have our applications where we have to fight all this sandboxing, and we're telling users, you've installed this, it might be unsafe because it's doing this tiny little thing. And at the same time, Plasma is just letting you download scripts and run them without that same level of warnings. And as a user, the expectations of what an app system needs to provide are increasing because this tech exists. I mean, I have boxing tech on my phone, and I'm comfortable downloading and running a Ryanair app next to my banking apps. But I don't feel the same about downloading some random thing off GitHub, even if I can see a source. I'd rather trust a sandbox than trust me reading a source, because I can't be bothered to read a source. So sandboxing is important. And that got me thinking about what else can we gain from this sort of technology. Moving forward, we don't have to care about ABI too much. Every time we make a new runtime, a new SDK of saying this is what you run your application against, doesn't have to be ABI compatible with the last one. And that would give us a lot more flexibility when we approach moving through KF6 to get to KF7. We can start deprecating things early and stopping apps using them and making sure they change. Or we can just be more eager to include new libraries into our SDK. It's safe to just make a change later if we want to. And also, bugs should be reproducible. My work is filled with Nate telling me he's got a weird bug that only he has. And in theory, in a world where we run the same software, we're in the same sub-stack with the same dependencies, should behave the same, and I'll have fewer of them. They won't go away. I'm sure you'll still find a way to out-QA me.
You always manage to reproduce them in the end anyway.
Well, debatable. Another thing that's going to be super cool, and I've not seen this really exposed or talked about yet, is I compile something on my laptop. It takes forever. I compile something on my desktop. It takes forever, even though I've just compiled the same thing. And it takes forever because my caches on my laptop are not usable. It's a different compiler I'm using. Things have a slightly different path or a slightly different timestamp. If you're building everything in containers, that problem goes away. So I'm hoping we're going to see SC cache used, or just copying your C cache folder and moving between machines, or even having somebody write a new merge request, and then me not having to recompile any of those files on the other side of the world is actually doable. And that could be game-changing. And the other important part is even if you don't like the Flatpaks and snaps, you don't have a choice. because they're coming, and there are distributions where it's the only way to get applications. So always immutable atomic distributions are coming up everywhere. And by immutable distributions, I mean ones where you download a distribution and you can't add or change any of these files. And every week is a new one of these. There's another one. No, and Fedora Silverblue spin-offs, MicroOS from SUSE, Ubuntu's got a slightly different vibe, and if you want to learn more about Ubuntu Core, KWin has a whole talk about it tomorrow, going into nitty-gritty details of that. One of these other products on screen. So what's this? So in these systems, the only way to get applications is through your stores with a Flatpak and snaps. And if they're not available in the Flatpaks or snaps, they may not exist. So there's pressure coming in that we can't avoid. And fact, most users will be using one of these distributions in the next few years. You might think it's a prediction, but it says fact on the screen. And I'm on stage, so I'm right. So what do we need to deliver for those distributions? We need our apps to be available, obviously, but I'm not going to blab on about that because that's hopefully been talked about over the last few years again and again. But we also need them outside that to be really small because it's often stored in duplicate. It's something that other companies promising as here a product, so they want to have some control over what they're offering. And as I talked about before, it needs to be robust. There's no point saying your apps are sandboxed if everything outside it is not. So we really need to focus on hardening that. And on the framework side, we need to come up with an SDK that works, something that's predictable. You look at your library documentation and see, here's a library documentation. I expect it to work the way Linux apps are being deployed now, which is in these Flatpaks and snaps. And we need to have that integration work and be clear when it won't. So what's the state in KDE right now? Things are enough. I mean, if SteamOS is a device that's out there, Silverblue's out there, people can get a lot of our apps, and they're available. But the experience could definitely be better. Like frameworks, what we're thinking about where we're going to be in 5 years is not designed with this Flatpak first approach. We've designed from that 20 years of history, 25 years of history of traditional packaging, and that's what goes through now. And that makes sense because that's how things used to work. Had distribution packaging where we give stuff to distributions, they give a random version to consumers, know what it is, and clients have to work around guessing, working against maybe building against this version of Qt with this version of framework, that mismatch. So we need to move towards this container-first approach where we think about sandboxing existing already and working. So before I talk about what we need to do next in frameworks, I need to give a quick summary of how all of the security stuff works in these containers. So by default, you can't access any of the files in home, well, with some exceptions, or your root file system. You can't just grab a random library that's installed and use it somewhere. No access to devices, which is generally a good thing. And when you want to talk to the other apps on the host, other processes on the host, it goes through a filter. And the host, so it goes through a filter, and these messages get filtered. Some messages can go into our application in the container, but the messages out from our application to the host get filtered. And very few are allowed. Also, the host system, Plasma, only gets to see a handful of files from the application. It gets to see a desktop file, which says how to launch it, and the command that says how to launch it gets modified by its install process. So where you say exec equals dolphin, the host sees exec equals flatpak run dolphin. Same for debus service files, so things can be debus activated. And again, that same modification of the entry point gets modified as far as the host debus daemon sees it. And obviously, we get a nice little icon. So those are static permissions. And you can do other tasks without needing those. So if you want to open a URL, you send a message to your portal, rather than actively you saying, launch Firefox, you ask a portal, please open this URL. And then magic things happen. If you want to open a specific file, you talk to your portal and say, can I show you a file dialog, please? And then the host shows the file dialog with all of your files and hands back a magic way that you can open just that one file. And we've got things like notifications go through this portal, things that maybe don't need any additional security things, but also something that we want to be restricted goes through this portal, and then we can show the user a prompt saying, do you really want to KWrite start recording your screen? Sounds suspicious. And the user can say yes or no. And the static permissions are somewhat of a fallback. If you go to FlatHub right now and you request to access all of your files in your home directory, you get a scary warning, full system read-write access. This is bad. And it starts to look like the back of a cigarette packet where you've got a picture of a lung disintegrating. And that's what's going to happen if you open .config. And another fact, over time, FlatHub's going to start making that warning more and more severe. And users are going to see that scary-looking warning and go, well, I'll choose between this application without a warning or this application from KDE with this giant scary notice. It's a no-brainer what you're going to choose. So we need to design our frameworks around this Flatpak first approach, where things by default go through not having big scary warnings. So I'll go through a few case studies, not going through everything we need to change in frameworks, because that's your job over the next 5 days and the next 5 years of working out where we want to take frameworks. So system tray icons. This is the icon in the little bottom right corner of the screen where you can see you're running KAlarm and you've left KAlarm open and you might want to do some quick access with it. So if you use KStatus notifier item or QSystem tray right now and try and use it, it just won't work. And that's a bad thing. But it can be avoided with one of these static permissions. If you --talkname org.kd.status notifier item, it can go through. But you have to know, as a packager, which you should be doing yourself as an application developer, that you need to add this. And no documentation in KStatus notifier item or QSystem tray icon mentions this. You find out, pardon? Well, yes, or outsourcing. No, on a serious note, right, we can change this one thing, but we need to approach this of everything, right? And I'm happy to make a merge request for this one thing, but what I'm hoping for is people go, this also applies to here. This also applies to KAutoStart. This also applies to whatever. And open up that discussion. And it's worth noting there are other ways to fix this at a Plasma and frameworks level. If we rename that dbus interface to org3desktop.portal.whatever, it gets allowed through without any prompts. It's a good thing. But it might annoy some people. So the alternative is we start talking to some people at the portals and, well, we have these requirements. We have this API. Let's make it work. And that means talking to your people, making an XEG desktop portal and say, let's do this. Wait, and Neil will take care of this. OK, we're assigning tasks during this talk, apparently. kconfig is like the core of all of our apps to load configuration files. And it works OK-ish. But on the base system, you install a version of Dolphin, and then you upgrade to your next version of Dolphin, and it's newer. And every distro has some way to do some meddling about, but it's complicated, and nobody does it, and it's unsupported. With a lot of these other operating systems, upgrading, downgrading, it's really surfaced as this user-facing API that you can do with a button. Right? You don't need to log into root. You can go on a Steam Deck, I want the beta channel, I want the main channel, I want the beta channel, I want the main channel. And people do this. And our code does not handle this well. So this is an open discussion of we need to fix this and come up with some mechanism to handle upgrades and downgrades. And the way we currently solve it is finding when people report a bug and then monkey patching it away and hoping that's the last one, which isn't a very long-term solution. The other problem we have with kconfig is that it has this very neat mechanism that you can have your global files in KDE globals and your application-specific files in your application RC, and it will transform into one single unified-looking file. So you just query something once, and it comes from this file, and it doesn't matter if it's a global file or application file. If we're in a container, we can't see that global file, so we cascade with. On top of that, if we do want to get global configuration values, which we can do through your portal, we can say, I want to grab this global config option from the host, we need to handle it explicitly. So we have a mechanism that makes it really difficult to see whether we want to do something from the global file or not. So over time, I think that concept of KDE globals is just getting in the way, and we should port away from that into the relevant files. Yes, things are complicated and software is hard. Shopping, OK Wallet. Yes, I'll explain how the wallet systems are meant to work in containers, and nobody really does this yet. The way it's meant to work is you talk to your portal and you get one password back. You don't know what your password's for, it's just one password back. And then you use this password you've got back from the host keychain to unlock your keychain. So it's this two-part system, and that way it doesn't matter what's being used inside a Flatpak. It could be any library to store all of the keys. That's not how KWallet works. KWallet talks to your host and expects you to query key value pairs of your keys. And we're moving to another library, which also doesn't handle this very well. So we need to think, this is where things are heading. Let's try and target that now rather than trying to do something now and importing again in a year. It's a very negative talk so far. There's a positive aspect. Kio, super core part of KDE. It's one of the big shining things of this is something we have in KDE, is Kio, which allows you as an application to grab something over FTP or Samba or NFS without going through horrible kernel stuff that doesn't work. So, does it work in a Flatpak? Sort of, ish. If you open KWrite, we also bundle our plugin to be able to talk over Samba, and it can load that plugin internally and load a file. But your password sharing isn't shared and doesn't work very well. And we also don't have file change notifications because that's on the host with the KDED modules. And if you allow your application to access KDED, lots of bad things happen because it can do a lot of things, like unload KDED. So copying what GNOME does is always a good idea. Their file system abstraction runs as daemons, and applications can talk to these daemons in a somewhat safe way and say, I've got this URL, can you open it for me? And even if you don't support that, their equivalent fallback, where we have Kio Fuse, they have GVFS Fuse, where you can use your normal POSIX API to open a file. They have that working. Our situation, a little bit ropey. Nico, did you want to say something? OK, he's shielding from something. The other thing we need to think about with frameworks, moving forward, not necessarily over the next 20 minutes, but over the next 5 years, is how we structure things. In KF5, we layered things based on their dependencies for external usage. And that's all we thought about, really. We need to approach this from the point of view of how is it going to be used, and will it work in an SDK? If it doesn't work in an SDK, maybe it should be a framework, but maybe it shouldn't be in the SDK that we present to people when they first go to api.kde.org. And we need to split these concepts. So I'll go through an example. KDE bus add-ons, very nice framework. Belong in Flatpak? Yes or no? Hands up for yes. Yes, sort of. Answer is complicated because some things yes, some things no. So people who are ambivalent, which is all of you, were right. So KDE bus service is a really important class for having a unified dbus interface that all 3 desktop applications are meant to implement. That's part of this framework. Yes, we want everyone to have that. KDED module is a thing for running things in the host. K-update launch and job, a very specific class for updating environment variables used by a daemon next time it launches something. No. Your clue is on there, but well done for that. So we've got a mix. And as we approach KF7, we need to look at saying, well, let's try and split this based on that. Will it actually work? And more generally, does KOF belong in the SDK? Yeah. Open questions. And does Baloo work in the SDK? It requires the database to be of the same version that the application is running. We can't really guarantee that. So maybe there's other ways to expose the contents of the database to applications, either through a virtual file system API, which we have all the code to do. There's a lot of options, but we should start exploring them. K-purpose, also plugins, doesn't really work. So we need to start approaching this. Somebody bring me my water, please. Oh, it's down there. Nate, can you grab me a water? Thank you. Flashing within Plasma. It's the other topic of this. We've got Plasma. It doesn't work very well. Plasma works very well. But the integration with applications and Plasma is very challenging because the whole point of a sandbox is to separate these 2 things. And historically, we've had this tie-in where we're saying, we've got this application in Qt. We're going to inject these plugins and try and manipulate it to well in our desktop. And that part doesn't work so well. So styles, your Q style, we allow people to choose it. And that's a plugin. Does it work in Flatpak? Kinda. Oh, I tricked you all. Yeah, it kind of does work. But also no. So as a user, you have to go and manually install, if we don't ship it, your Q style on the host, so this KCM sees it. And then there is a mechanism to add plugins into a SDK that we provide. But it's not hooked in from this KCM, and that sort of falls apart. And even if it did work, it's sort of under the sandboxing if you're grabbing these external plugins and trying to mess them around. So we need to move away from this concept of injecting things into other processes dynamically. So there's a talk tomorrow from Ian about a new way to approach styles where we say, let's try and just use one style and then have other ways to theme this, which is based on configuration values rather than injecting binary things. The other plugin we inject into application is a Q platform theme. For most other applications, it's hosted in Q Plasma. We host it in Plasma and release it in lock sync with Plasma releases. But that doesn't get loaded. So on the Flatpak side, they grab this repository and also bundle it in whichever Flatpak SDK release we have. So that also somewhat falls apart because you might be running an old version of Plasma integration on a new Plasma, which requires us to keep all of these things in sync so it actually keeps working. Can we use container tech to improve Plasma? Yes. This is a positive bit of the talk. So I'm going to go for a case study of how other people can extend parts of Plasma. which is the opposite way around, rather than apps, Plasma extending applications. So KRunner. It used to be a plugin systems. We had KRunner, it was a framework, and people could write binary plugins that Plasma then loaded. And that gets you so far, but only stuff that distributions then packaged. It's very difficult for third parties to do anything that any user can actually use. So we tried to move away from that. And we moved to a process where KRunner talks dbus, IPC, to another binary in any language that gets launched through dbus activation. We say, user search for your word foo. Do you have any results that match a search? And then we display them, and maybe invocation. And we landed that in 5.27. And users started shipping this stuff. And on Get Hot New Stuff, a KDE website, we have 50 plugins, not plugins, sorry, 50 ways of people, 50 runners, thank you. And then those scripts were just bits of Python, things that you can just randomly run, because they're scripted, you can just download and run them. Except that's not even how scripting languages work, they still have dependencies. So those scripts started calling apt-get and RPM and pacman and doing horrible things that script not be doing. And we started supporting that. And the result's a mess. So we want to use that same amazing infrastructure that Flatpaks and Snaps provide. And there's nothing fundamentally stopping us from making that work, except for some tiny details. We required a desktop file, this config file that says, I'm a runner, run me, to be installed into user share KRunner dbus plugins, which Plasma can't see, because the Flatpak environment doesn't copy this file to anywhere a host can see. So fixing is easy. Just move where that file is to a file that we can see. And I ported one of these runners to be in a Flatpak. It was a 2-line change, and now we can start getting runners in Flatpaks. But it's also interesting that GNOME had the same problem with their identical framework, GNOME Search, and they patched Flatpak to just also copy a file, which is the approach we should be looking at in terms of how can we fix these. Just modify a software that gets used is a valid approach. And we have the same problem in a few other places in Plasma. Solid device actions, when you plug in a USB pen or your SD card, you might want to automatically open it in Gwenview. And you can write these rules that say, if it's an SD card and there's a folder called dsim, open Gwenview. And that absolutely can work in a Flatpak world, but the host needs to better see these files. And we have this really nice feature that we all love, where we can configure our application notifications in Plasma. And I like it, but it's not going to work for any Flatpak app because it requires reading a notify RC file that Plasma can't see. That needs a solution, or it's going to just end up in the bin. Another case study, file thumbnails. File thumbnails are really important because tricking a user into plugging in a USB drive or downloading a file is relatively simple. You don't require social engineering to make somebody download a file. Making them open it, sure, but then hopefully it's in that sandbox environment. But to show a little preview of it, someone needs to open the file and look at the contents and make that little preview. So it's currently shipped as plugins that have to match the same version of Plasma that we are running right now, or the same version of Dolphin. If you've got an app like Blender that wants to install its own thumbnailing tool, it can't because it can't export a file to do so. And they currently run on our host completely unisolated. And I'm pleased to say that should allow Flatpak apps to make your own thumbnails and start sandboxing the stuff we have, which is going to be awesome. And long term, we need to be thinking about using this container tech for all applets, all of our extra KCM modules, so they don't have to be inside our base. And that requires some new infrastructure that doesn't exist yet. but hopefully that's something we can work on over the next few years. And I intend to work over the next few years. Questions? Or lunch? Snack? Nate, do you want to just shout? Oh, there's a microphone here. OK.
Does it work? Maybe?
Yes,
okay, it works. OK. So I'll be brief with my question. What do you think is the ideal balance of changing our apps to work with Flatpak versus changing Flatpak to work with our apps?
About a 5. I think it's a compromise, right? It depends on the situation. We should try, and we can say we've got. If it's no work for us to change, then we should just change. If there's a benefit to changing Flatpak, we should change Flatpak, and we can or at least try our approach and see what works. So there's no right or wrong answer to any of this. There's a see which is the path of least resistance.
So I have seen complaints about the free desktop secret service, as in it gives you a false sense of security because actually everyone can see everything. So how is your work going to make this better or address this issue?
I think there's a difference between where we want to go and where we are now. We're approaching this in a very transitional way of let's actually get apps using this framework and then tighten and tighten and tighten and tighten, rather than what we've seen in some other transitions of saying, this is a perfect world we want to jump to, and then everyone's struggling to actually make anything work. And that's a balance. And I think it was just something that we're just going to transition time. And you're right, right now, maybe there's a false sense of security, but the alternative is also not safe at all. So as long as we're transparent to the user, that should be OK. And I think our transparency is really important. And that's something we can definitely make sure is right. And that's something on us to fix. But the technical side is just about time and putting in that effort.
So a free desktop secret service and the secret portal are actually very different things.
Yes, sorry, I missed your question. Secret service. Yes. Yeah, sorry, yes.
Secret Service basically has the security model of KWallet, which anything can access anything.
Yeah.
But the portal is the thing where you only get that one key.
Sorry,
so that should be secure against that.
It should. But we need to actually make use of that. And I should mention on the KWallet side, Carl has a talk, a BOF, on Tuesday about wallets. So if you're interested in wallets and Secret Service, and the other Secrets Portal, go to that, and we can make sure we come up with something that works and is amazing.
That would be good, because secrets are a mess right now everywhere.
Yeah. But I've been following what GNOME have been doing on the project that got your sovereign fund money, and they were open to collaboration on the daemon side.
What about running more Plasma core services as Flatpak? Like, for example, running kscreenlocker in a container, or KWin, or maybe even krunner?
I think definitely over time, it's one of those, let's keep adding and adding and adding and adding. The things with Plasma are always a little bit difficult because we need to launch applications and do all of the things that we need to do. So I would like to see more because I want to see that core reduce. So I think the important part is to get things like Print Manager out so that I can have a different release cycle and those sorts of things out first, and then the core stuff comes later. So really focusing on that cost-to-benefit ratio. If there's a huge benefit with little cost, that's what we do first, and then work our way down.
So.
See, I know it's going to be bad, right?
Is it working? OK. All right, there we go. So you talked all about how this, sandboxing and permissioning and all this fun stuff that you want to have in applications, SDK, Plasma, things.
Some sort of KDE goal, if you will.
I'm not going there. But I kind of think that the actual thing you want is to see the Plasma stack as a whole operate with the assumption that there's a sandbox and that we have a sandbox delivered with a manifest that executes on that.
Yeah.
I don't think that necessarily means we're coupling it with Flatpak.
Right.
Like there's a tool out there that I saw some months ago called Bubble Jail, and it basically takes the same security containment manifest that you use in Flatpak, and it takes it out and you can use it for arbitrary application processes and services regardless of delivery system. This is something that could make a ton of sense for us to use now to start moving towards a sandboxed model for sensitive processes.
100%. I mean, it's about using the right tool for your job. And if stuff is coming from a third party, you need to think about a distribution as well. If something like the thumbnails we talked about, if they're from KDE, yes, I still want to sandbox them, but I don't need to worry about your distribution. At which point, you're right, we need a tool that only covers that one part of your job. I think we've got time for one more question.
Is there, from what I understand, your focus is top level, so to speak, application and not the base system. Do you know if there is any work on KDE working to make it more easily to work with immutable OSs like macOS that uses read-only stuff like read-only user?
I think maybe hang around today, go to Howard's talk. Is that, yep. Hang around today, go to Howard's talk and have a look what he's doing. What's the name of the cool talk?
An operating system of our own or something.
An operating system of our own, and that might have some similar concepts. I've been told to stop, so I will leave. Thank you.
Yeah? Oh yeah, no, I think it works. Right? That microphone, yeah. That one also works. How long is this? 40 minutes, apparently.
It's a missed opportunity to call it State of the Union.
Well, no, that's going to be next year's talk, because right now I'm just introducing it. So it would be a bit weird to call it State of the Union if we don't know yet what union, right? Yeah.
Dismiss it, and that's why I've been looking for session chairs. I can do it for now. Okay. In case
You just got promoted to chair, I suppose.
like at the end of the session, not just like at the final, like we're having the launch of Sandbox, and we also have other groups of our sponsors who visit them.
Is that like a time?
Yeah, like after 6 when it is the last session.
Okay. Okay, right.
So, I hope you all had a nice coffee break. Thank you for being here. I'm not supposed to be its session chair right now, so I should have come up with a joke by now. And then Eike stole my joke about the State of the Union, and Ian doesn't want me to introduce it as the State of the Union, so I'll just leave the rest of the introduction to Ian.
That's fine. Hello, my name is Arjen Hiemstra. I am here to talk about a project that I've called Union, which I hope will become the future of everything styling within KDE, and maybe even more than KDE. So what I will start with, though, is some pictures. So most of you will probably have seen some of these things. I'll start with, this is Kate. This is Plasma, also quite familiar to most of you. We have NeoChat, might be less familiar to people, but will still be familiar to a lot of you here. And then we have an application called K-Clock, which isn't familiar to most people, but still also a KDE application. So that's all great. We have 4 applications that look quite similar. So what's the problem here? Well, we have 4 applications, and we have 4 different implementations of the Breeze style. We have Kate using cute widgets, using Breeze. We have Plasma using Plasma style, using SVGs to supply that information. And then we have KWin, which in the case of NeoChat is its own special thing. And then in the case of KWin, it actually uses a KWin-based implementation of the Breeze style. I hope that all of you recognize that having 4 different implementations of the same thing is already a problem. But sorry? Yeah, I'm intentionally didn't mention that one here, mostly because that's a whole different can of worms. But yes, you're right, there is a potential fifth in that we also have an implementation of Breeze for GTK. So apart from that issue of having 4 different implementations, there are also issues with the individual implementations. Starting off with the Qt widgets implementation, which is built using the C++ QStyle API, which is, to put it politely, not the greatest API for doing stuff with this. I actually put up some code from the Breeze style. Basically, you need to manually paint all the individual controls, and it's very painful to make any changes to how Breeze looks in QStyle. It takes a lot of time and deep knowledge of how QStyle works. So this is really not that great. And similarly, an additional problem here is that it is limited by specifically those types of widgets that QStyle supports. So if you have a custom widget, which we don't all that much, but if you do have, it also becomes quite hard to reuse the styling from QStyle. On the other hand, we have the Qt Quick side, which is better. Qt is styled using Qt Quick control, or Qt Quick control specifically is styled using QML files, which is already a lot easier to work with than QStyle, but it still has its issues. Specifically, one being, if you make a mistake in your Qt Quick style, you can break applications, which is dangerous when you want to include a custom style in, like, say, or inject a custom style in something like a Flatpak, which is a use case we do have. So to sort of get around this issue of having multiple implementations of the style, at some point we developed the Qt Quick desktop style, which makes use of the widget style to render controls for Qt Quick, which works since we have a bunch of things that don't require re-implementation. But it also comes with its drawbacks, because we're now limiting our Qt Quick side by what the QStyle side supports, which isn't great. It also comes with another drawback, because QStyle is software rendered, which means that on like mobile platforms, you now have an issue where the performance of this isn't great. So at some point, Noah Davis built a version of the Breeze style using pure Qt Quick, because that was targeted to help make KDE applications work better on Plasma Mobile. And that it did, but it didn't mean we had yet another implementation of Breeze. And then finally, we get back to Plasma, which has its own SVG-based system for styling, which is actually pretty decent to work with for non-developers. But even then, with them, when talking to them about it, it turned out, yeah, it's better to work with than, say, Qt Quick, but it's still an issue because SVG is not a format designed for making UIs in. It's a graphics format meant for making images. It's still not great for doing UIs. It actually also runs into the issue that you now need to render these SVGs, which comes with their own problems and performance penalties and everything. And additionally, the Plasma styling still contains information that is encoded in the Qt Quick that's making use of this, to identify which elements to use and all those kinds of details. So I think you can all agree that we have a problem here. We actually, within the visual design group and some other areas, we've identified this problem a while back. And it's taken a while to get to a solution. But basically, the question becomes, we have this problem. How do we move forward? How do we get to a next stage? So yeah, we need something new, because what we want to go to is the classic case of, hey, we now don't have 15 standards, or 5 in our case. We now have just the one, and just that one thing that we can use to build our UIs with. So just to work on, hey, what are we going to do with this? I came up with some requirements during a long process of getting to where we are now. So the main point being, we need something where we have a single source of truth for all our styling. This is something that also our designers want, because they want to make changes to how things look. But right now, they are being blocked because we as developers say, hey, sorry, we like your ideas, but we just can't do this because it's going to take way too much effort and way too much work to make these changes. And in some cases, it's even saying, yeah, well, we can't technically do this here because we're being limited by, for example, Q style. So one of the main requirement is we need a single source of truth. We also need to make sure that that single source of truth is easy to change, and easy to change for people who are not necessarily developers, because we want to be able to work with our designers to make it easier for them to implement their vision of how things should look. On the other hand, I also have some requirements, and those come from my side, from the technical side, because I want to make, if I'm going to work on this, if I'm going to build something for this, I want to make sure that I can build something that is optimized for our target. So if I'm building something and I want to target Qt Quick, I want to have something that uses Qt Quick hardware acceleration to render. If I'm using it in, I don't know, if we're going to use it in a crazy idea in a game engine using Vulkan, I want it to be able to use Vulkan internally. That's one of the things. The other requirement is that single source of truth should not have any logic. And this is a technical requirement from my side, because if we don't have logic in there, it means that we can do a lot more optimization on the library side with this on this input format, so that we can do more intelligent caching that doesn't need things like, oh, hey, state change, so I need to call back into whatever gives me this information, and it needs to ask that to re-render something. No, you can just say, okay, state change, here, have this different thing. And it needs to be flexible enough that we can define custom types. Because within KDE, we have the Kirigami library, which implements a whole bunch of custom controls on top of Qt Quick. And there is no way for you, or, well, there is a way, but there is practically almost no way for you to restyle those into style. So if you go and use a Kirigami application under GNOME, it will look like Breeze, at least partially. So with those requirements listed, let's look at how I got to where we are currently. So at some point, while working on this entire thing, which has been a long process, I came up with this idea: what if we separate things? What if we say, hey, we have some kind of definition that defines how things should look, and then we have an intermediate layer where that input format can get transformed into that intermediate layer, and then we have an output format that consumes that intermediate layer instead of the input format. The main difference this makes is that if something needs to change, if we want a different input format or whatever, we don't need to change the output format. If we want to add a different output format, we don't need to bother with the input format. So that was my idea at some point, and I basically came up with, hey, could we use this to build something where we use CSS as an input format, read a CSS file, read some definitions from that CSS file, and use that to style both a Qt Quick application and a Qt Widgets application. So I built a proof of concept of that a few years back at this point, proving that, hey, yeah, maybe we can actually do this. So I built this using a CSS parser that I found somewhere on the internet, which is its own issue. I'll get into that a bit later. And it built this very minimal intermediate layer that this CSS converted into, and then built a Qt Quick style using some of our standard stuff, but using the information that came out of this intermediate layer to render a button that looks somewhat like how Breeze would style it. And then on the side, I built a Q style that used that same information and then did the same thing and ended up rendering a button that looked mostly the same to the Qt Quick side. There's some bits that are not entirely the same, but it was mostly because I ended up not wanting to spend that extreme amount of time to get that rendering right. So what can we learn? What could we learn from that proof of concept? Well, most importantly, the core of my idea seemed like it would work and it would be possible to have something where we have a single input format and 2 or more output formats. Of course, it also means that, hey, yeah, okay, so we have this, but it means that we're basically going to need to rewrite the entire set of how we do our styling within KDE, which is going to be a lot of work. Yeah. And also something from the proof of concept. As I mentioned, it was using CSS. CSS is a problem mainly because there are no good CSS parsers out on the internet, at least not for what I want to do here. Like there are plenty of CSS parsers around, like in web browsers and stuff, but none of them are available as a C++ library where I can get a parsed tree of what CSS file, because most of them go like, oh yeah, here have a styled thing already, or stuff like that. And because, as I mentioned, it's all going to be a lot of work, so we need some way of splitting up this thing, because rather than building this monolith somewhere in a dark corner of KDE, and then at some point going, look, here is my thing, it's done and it's going to be awesome, and then real world hits it and it turns out to shatter that entire monolith. We need to do this in a more step-by-step way, so that we can prove parts of the implementation are correct. So this proof of concept was done, I think I presented it to people during Academy 2022. And then it kind of didn't go anywhere because of various reasons. But I did mostly because I didn't have the time for it. I did spend on occasion some time on, hey, okay, let's make a production version of this. How do I go about this? And this is how the project that I now call Union came about. And it's meant to become this single source of truth styling engine that we can use to get our styling into a shape where our designers aren't running away screaming. So again, I get back to how do we go about this? At some point, when we were discussing this, a fairly smart guy who you may have heard about, called David Edmondson, suggested, hey, what about doing it as, what about just re-implementing the way Plasma is styled using this engine so that we know what the input format is, we know what the output format is, and we have a way of a thing where we can focus on that intermediate layer, because a lot of stuff depends on that intermediate layer, and if that intermediate layer sucks, then the entire thing will suck. So that's basically what I've been doing for the past several months, because finally we found someone came with, hey, I also want this, so I'm going to give you guys some money for this. So now I suddenly do have the time as part of my day job to work on this. So it's finally making progress, luckily. So what does that look like? Well, it looks like this. The left two buttons are being rendered by Union, are using styling from Union. The right two buttons are using styling from Plasma. It doesn't look well, apart from the icon, ignore that. It doesn't look any different at the moment, which is exactly the intention, because right now what we are trying to do is recreate Plasma styling, because that's what now we know what that needs to look like. So we need to come up with all the constructs to make sure that with that separation of concerns about having the input layer, which now reads Plasma SVG, that converts all that into this intermediate layer and then goes into a separate Qt style that makes use of that intermediate layer and puts out something that actually looks like what Plasma does. So some implementation details about that. We now have a core library that basically is built around a concept of a theme, and a theme has a collection of style rules. And a style rule is, well, I'll get into that in a moment, but it has a collection of style rules and selectors. And then we have an input plugins, currently only one that reads SVGs and converts that into a bunch of style rules. And then we have a Qt style implementation that feeds information into the theme, and with that information selects which of those style rules apply to the current thing that it's trying to render. So style rules, I mentioned that. Style rules are which properties do apply to this element. That's the most generic description I can give you of this. And importantly as well, style rules have a selector. That selector determines what kind of elements this style rule applies to. So you can have something that says, hey, my text color be red, and this should apply to any button. Or, and if we have a button that is currently focused, rather than using red, it should become blue. These kind of things are encoded using the style rules. And they are, effectively, they form a stack where the topmost property is read first, and if there's no value in the current style rule for that, the next one is used, etc. For those who have experience with CSS, this may sound very familiar. That is kind of intentional, partly because I was inspired by CSS, and partly because I still want to be able to use CSS eventually, but that's also a thing I get into. Sorry, how much time is left? 15 minutes, okay. So that's the current state. What's next? I want to finish up this plasma style thing and basically get that into a state where we can say, hey, we deprecate plasma controls, the plasma specific implementation of the styling, and use union instead, so that we can get some real testing of this. We need to implement the Qt widget side, which is going to be its own dragon to slay. And we need to decide on a new input format, because SVG is not meant as the final input format. As I said before, I still really prefer would like to use CSS, but that's tricky with library things. There might be a solution in using a Rust CSS parser, but yeah, that's still in the investigative state. We also need to do a bunch of application integration, because Union assumes that a bunch of the information comes from the application next to what the style can already provide. But as a simple example, we have this header area in our applications. With Union, my intent is that the application will provide us information about what is defined as its header area. And there are some other things. We have a bunch of things where we use styling, Breeze-like styling, and as well, mentioned here, GTK is a thing where we currently have a custom CSS. We might be able to use this to generate a CSS style. But that depends also on whether that GTK styling is actually maintainable, because from the GTK side, there's a lot of push about, hey, don't theme my apps and all that stuff. So with that, I come to the end and would say, any questions? Yeah.
The code on the Plasma side knows how to use that as the contract. Can you walk me through where does that match up happen in this re-implementation? Because you mentioned the output plugin that you currently have is just a generic quick one.
Yeah.
But where's the sort of Plasma knowledge?
That's on the inputs plugin side. So in the case of Plasma SVG, we actually have 2 layers there, because we have a bunch of definitions in YAML that which elements should be used for certain controls.
Could you explain how your work on this has any implications about using a like Qt app in a desktop environment that is not Plasma?
So the intent is eventually that we can have different input format, different input styles that implement platform-specific styles. So rather than having to rely on a bunch of different elements coming from different styles, we have a single source of truth that might be, but it also might be a Windows-specific thing, or a GTK-specific thing, or whatever. Or and I've not mentioned this intentionally, but if someone wants to go and do third-party a third-party theme, they can style the entire. The intention, at least, is that they can style the entire Plasma desktop using their own custom theme.
Have you looked into the integration with the Qt palette and the palette configurations for Qt application together with this? Because Qt application can also provide their own styling information using the palette.
Yeah, right now it doesn't do that because Plasma styling doesn't do that. It is a thing that we will need to look into, especially for Qt and Qstyle. We do actually have some experience with this already on the with the desktop style, Qt desktop style and things like that. We already do some integration with Qt Palette. Fortunately, it became harder with Qt 6 because Qt Palette in Qt moved from being a Qt Palette to a Qt palette. That's a different discussion, but yeah, that's definitely one of the things that we do intend to support.
Hello. It happens that we have a CSS style in Qt widgets. I assume you have looked at. That includes a CSS parser and also a similar architecture around rules, from what I understood from you. One of the challenges we have with the CSS style or the style sheet style in Qt is, of course, tries to know which aspects of the UI you have styled using CSS versus where it fall back to the default style. Do you plan to do something similar magic, or do you agree with me that by not having any kind of default behavior, everything is unstyled? If it's not explicitly styled, we just draw everything as rectangles. We can remove a lot of that complexity.
So I agree with you in there that no, I am not planning on any fallback behavior there, or at least no low-level like per properties fallback stuff. We might be able to do something with higher-level fallbacks, but yeah, the intent not to have complicated fallback mechanisms there.
On the topic format, CSS is quite powerful with animations and logic constraints. How much do you actually want to support from that? What large feature set?
That's currently an open question. It's something that needs to be investigated when we're actually developing a CSS input format. Like animations are something that we will want to support simply because we want to be able to use that for Breeze stuff. But maybe not all the types of animation. I'm mostly thinking like transitions we would want to support, but maybe not completely free-form animations. And there's also things like media queries and stuff. What do you do with that? Advanced selectors are, yeah. You're completely right. CSS, especially what's becoming CSS4, is quite complex and large, and we'll have to see how what we can support, what needs to be supported.
You mentioned something about custom control. How do you currently do that in using Qt style? Because you need to provide this template for all the controls that we currently support. So what is your solution for these custom ones?
So as I mentioned, currently the solution is that we style them as Breeze. And we don't, there is on the Kirigami side, we do have a construct where we do support like having a template where that you can re-implement, but in practice, basically, almost no one does that because it's just a lot of work and ends up being very complex. So the end result is basically that we always have Breeze-styled custom controls, unfortunately.
So previously you said there would be like no fallback behavior, and yeah, I'm sure that makes sense. But would it be possible for like a user to say, oh, I want my theme to inherit from this other theme? Like let's say a user says, I like most of Breeze, but I want to change this bit.
Yes, that will be, at least I do intend to support things like that. It will be up to the input format on how that works. Like with CSS, I just end up being something like, hey, import Breeze and in the CSS file, and then override some rules. That it's one of those areas where I think it is up to the input format to determine the best solution.
Have you looked into the GTK CSS styling, if it's something like that can be used, so we at least get a bunch of themes for free automatically if you use the same CSS style?
Yeah, you're not the first one to mention that. I have looked at that and basically concluded that it's probably not feasible for us, unfortunately. Also partly because of current attitude of GTK developers towards this. So I am quite hesitant to go and reuse something where they say, no, this is ours and you must not touch this.
I was hoping to revive Advaita Qt, but sadly no.
While the implementation part is another story, for this architecture specifically, while GNOME and GTK side is a little different on that, for this intermediate layer, would you consider contributions that cover more than the Qt for other desktops like Cinnamon, etc., to make it from KDE into a more free desktop thing, possibly?
I mean, if there's there, yes, I would definitely consider them. I am open to like have this integrated in more layers, also to make it easier to run KDE stuff on Cinnamon or something. So I would totally be open to that. We need to figure out what the right place for such things would be.
So in my mind, I'm kind of getting hung up on the details. On the notion of custom controls, I'm curious if you can give a little hint how you plan for that intermediary layer to be extensible. Because you mentioned one of your requirements is that the input side should be logic-free. But in your re-implementation, that's currently not the case, because you have the input plugin reading the SVG, doing the magic translation of this should be a task manager button, these are the elements to the intermediary thing. But in your future input format, the input would be more generic. So how do you transport the notion that there is not just a button, but there's also especially just, let's say, a task manager button, which doesn't occur anywhere else, into that? How do you extend that? I'm curious about that.
So I'll correct you on one thing. The input format the format needs to be logic-free. It's not the plugin that needs to be logic-free.
You don't consider the plugin to be the
No,
input.
the plugin is the thing that translates the input format into the intermediate format.
Okay.
Yeah, and I run out of time. I'll
That
gladly
already
talk
answers
about
a lot,
it in,
so,
in detail
yeah,
with
thank you.
But then I can actually show you some code.
That was very great. Thank you for that. So up next, we've got a quick 5-minute break for you to get to your next room, your next talk, what you want. Over in room 1 next door, it'll be an operating system of our own. And in here will be Qt Beyond 8. See you in a bit.
Lovely, because we are thinking about the exact this.
Yeah, I figured. I already heard that I got some attention from you people.
At the right people in the room, I think, I hope. Just trying to say the obvious. So there's definitely some good reason to think together.
Yeah. Hello.
I'm Doris. I work on KWin controls and
Okay.
styling. Great talk. I would like to ask you some more questions.
Yeah, sure. I think we'll leave Volker to prepare.
You want your power? No.
Yeah, if you can plug it out. Oh, and I shall also give away the microphone.
Okay.
You're on.
Ta-da. I think this is my water bottle.
Welcome. Welcome to our next session. In room 2 here, we've got Beyond Qt 6.8. Take it away.
Thank you. Hello, everybody. My name is Volker Hilzheimer. I'm the chief maintainer of the project. I have seen some of you at the contributor summit that we had in Würzburg here earlier this last week, where I also talked a little bit about what I think is the future and the challenges and the opportunities for us in the Qt project beyond 6.8. This presentation touches on some of the same points, going a little bit deeper into specific work items and technical bits and pieces, but it's not a very technical presentation. Yeah, beyond 6.8, we are about to release 6.8 during September, perhaps in early October. We have a couple of pending header review discussions. Those of you who are contributing might be aware of it, but I hope we get those resolved fairly soon and then can ship 6.8 as the next LTS release. Let's talk a little bit about what highlights are going to be in 6.8. Of course, before we start thinking about what's happening next. So in 6.8, we have a whole bunch of stuff related to general UI improvements that are relevant, I believe, for KDE, such as, for instance, an application can now actively request dark or light mode. We have more controls over certain aspects of font selection. We have better support for vector graphics, such as SVG rendering. Hartem here can give you the details on that one. Qt Quick on the desktop has been a big focus for us now in Qt for several releases. What we are introducing in Qt 6.8 is a better integration, or actually an integration, into the native menu bar system on macOS for menus in Qt Quick. So we used to have these platform lab stuff that you might have used before. Now the menu and the menu bar that we have in Qt Quick is actually talking to the menu system on macOS. We are also doing some work on pop-ups in general, so that they, on the desktop, are not eyed within the QML scene, but rather top-level windows, like you would expect from a dialog, for instance. Thank you for the feedback from the KDE community that we got in that respect. The defaults, changing defaults like that is, of course, always a bit problematic and confrontational because it suddenly changes existing user interfaces, which is not always an improvement. But yeah, both also on the layout management, making layouts and control behave differently or behave like you would expect it from resizing windows, for instance, which control should get that extra space. That is something that the layout system and widgets had for many years. And in Qt Quick, we so far haven't had that, so we make a couple of additional facilities in that one. Also, some of the item views that we have, the table view, tree view, and so forth, have now better control for certain interactions. On the scene, on Qt Graphs, data visualization, that has been a new module replacing over time Qt data visualization and Qt charts into a module that is sitting on top of the modern Qt 6 rendering stack and the QML graph. So this is something that is now moving out of tech preview, which is great. A whole bunch of work has gone into networking support and web service consumption APIs in Qt so that you can easier work with distributed systems using gRPC, using protobuf, and also running your own HTTP server. That has been work in progress for several releases, and now we are taking those out of tech preview, which is great. And Qt Multimedia, a bunch of work has been done there to both allow you as a programmer to define your custom pipeline using programmatic I/O APIs, feed your own images, for instance, into an encoder, or decode images or audio into PCM data that you can use for post-processing. And perhaps interesting for you, support for Wayland, somewhat experimental still, but for screen capturing. So that's not everything that we have in 6.8. Look at the documentation, the What's New page on the screen. This is what I consider to be the highlights. So what are we now going to do beyond all of this? Are we done already, or is there more to do? I think there is more to do. So beyond 6.8, we want to definitely make it easier to use Qt Quick and use QML for anyone out there. Right now, we have a very strong focus, of course, on C++. C++ developers using Qt and also then using QML and Qt Quick to build their user experience. We want to support more languages, and we want to make that technology, Qt Quick and Qt QML, to more developers. We want to reach people that are developing software in Python, in C#, that are building Android applications. We have earlier seen from Joshua, I think, the Rust talk, which I think is going to be super interesting for us as well, how we can make it easy for Rust developers and Rust applications to use QML for their or QtQuick for their user interface. So that allows reach a whole new group of developers that we are not accessing and not able to talk to or make anything in for today. It gives hopefully QML a big boost in new people that can actually understand that language and develop in that language. And QtQuick, of course, as a great user experience technology. Also from a styling perspective, we saw some of that earlier in Arjan's talk. Yeah, we want to focus on more things related to workflows as well. So turning Qt into an open framework that is really available on any kind of development environment. So it starts with the tools, it starts with the development experience. Yeah, making it easy for people that have existing code to use Qt and QtQuick in their application, even if it's not a Qt application. So you have perhaps seen the blog that we are now making it easy for people that have a .NET application to use QtQuick as well on top of that. So these are the kind of things we want to make really easy. One challenge that we see, and I think we also see that, or you see that in KDE, and we got that feedback already during discussions over the last day, it is not a perfect developer experience yet to build a QtQuick application. It comes with a certain friction and a certain overhead to have both your C++ entry point and your application logic, and then you need to get the QML and the QtQuick code in there. You have a hybrid kind of development environment. How can we make that easier? If we add more language to that, that doesn't necessarily make that easier just by itself. It just makes it easily or similarly hard for everybody. So making that experience easier by having a better concept of what could a QtQuick or QML runtime look like, where we can package a whole bunch of sources together into a well-defined format so it's easier to deploy these things. So these are things that we are thinking about, making it easy for a hybrid application built with multiple different technologies, multiple different languages to be patched up, deployed, debugged, iterated over. Technically, a big part of that is also make it easy and possible to combine different UI technologies. So we just heard in the previous talk about widgets, SVG, QtQuick. We have native frameworks, of course, on the different platforms, on Android, or on iOS, or on macOS, or different systems used to build applications also on Linux desktops, of course. Can we make it easy for people to combine those different technologies into a consistent user interface, into a consistent user experience? So the problem that was just earlier described about, okay, you have a quick application using a style implemented using QtQuick technologies. You have a widget application using the same style, but using a different technology. Imagine that when people are combining QtQuick and Qt widgets inside of the same application, inside of the same user interface. And that is something we want people to be able to do and make it easy to do. Because some things, there are lots of widgets applications out there. There is nothing stopping people, hopefully, from using QtQuick for some aspects of that user interface, putting a QtQuick widget inside of their widget application, and then running your QML code inside of it. How many of you are doing that? How many of you are using QtQuick widget today? Unfortunately. Okay, so we want to make this easier. We want to make this less frictionless. Qt 6.8 has a lot of good facilities there to combine QtQuick and Qt widgets. But then, of course, you want to have a consistent user experience. Your button on the widget side of the application and your button on the QtQuick side of the application should look and behave similarly. You want to be able to tab from the widget side of the application through the QtQuick side of the application to the widget side of the application again, right? Tab focus, accessibility, modality, all these user interface concepts, drag and drop, they need to just work. So that's a bit of work for us beyond 6.8 now, figuring some of these complexities out, and yes, also, of course, thinking about what kind of unified styling architecture could we have so that you or users otherwise that want to have a custom style, or where we want to make sure that the entire application follows the native look and feel on macOS or iOS or Android, that we have a consistent look and feel across the entire application. That's a really hard problem, as we just saw. Lots of good ideas already in many people's heads, so I hope that's a good opportunity for us to also collaborate on that one. All right, so that's one big topic for us, making Qt an open framework that is also easy to use if Qt doesn't own the entire process or the entire screen. Then there is, of course, a trend that is very important for us as a cross-platform framework, used in many different industries, used in many different geographies, and that is just simply computing fragmentation. So both on the hardware side and on the operating system side, we see a lot of things happening. ARM is now coming increasingly to the desktop. macOS has been, or Apple has been leading the pack on that side, but we see it, of course, from Microsoft with Windows on ARM. Linux on ARM has become more and more relevant, especially in Asia Pacific. We see new architectures also in China, for instance, becoming important and relevant. MCUs as a very lightweight computing platform is important for us, and we want to make sure that people that know Qt can also target MCU devices and architectures with our technology and with what they have learned. On the other hand, we see a lot of convergence of user expectations, at the very least, from mobile to desktop and into the embedded space. People have the expectation that user interface responsiveness, user interface design quality are becoming more and more the same across all different computing platforms. So tablets and laptops are more converging and harder to differentiate. You see increasing amount of laptops, for instance, that also have a touch screen, or where you have mouse, trackpad, and touch screen all together in the same time. KDE goals on having input management be very well done, I think is super relevant for us, and I think there is also not just a possibility to collaborate, but a need to collaborate, because event handling, understanding multi-seats, for instance, you have multiple mice talking to the same, interacting with the same application. How do we express that correctly in the framework? So there are a lot of things that we need to do there. And then there are, of course, completely new experiences, environments that we are working on. So XR, for instance. So there's a whole bunch of things that we are doing. I mentioned already hardware architecture, operating systems, regional developments, staying in touch with what's happening in different parts of the world. XR for us is a really big opportunity, making Qt a cross-platform framework also across the different XR architectures or VR devices or VR platforms. So we have MetaQuest, we have Apple with Vision OS, we have more different devices coming now, and we want to make it possible for, of course, to create an experience on different immersion levels using Qt that allows them to deploy that experience to different XR or VR or AR technologies and headsets. And that's quite interesting because that comes with a whole range of new challenges from a user interaction perspective. It's no longer mouse or touchpad or touch screen, right? It's gestures. It's pinching and gesture recognition. It's locomotion in a virtual environment. So there are a whole lot of new things that we need to figure out and solve, and that's very exciting. Some of you might have the opportunity to test out our XR support or VR support at the Contributor Summit earlier this week. So lots of good things happening there. And yeah, being a cross-platform technology in this space as well is what we are trying to figure out. So there's a lot of stuff that's different. Some of it is not so different, but it's just a new platform. So the low immersion mode, for instance, on the Vision OS is not all that different from running an application. But there are some differences still, and we need to make at the very least sure that you can deploy a Qt application as a native OS application rather than as an iOS application. So some work of that has already been done and will be released with 6.8, but that is, of course, just the beginning of that journey. And then we have also distributed software systems, where the application front end and the application back end are decoupled, like we know from the typical web architecture or web service architecture, front end being in Qt Quick, back end being wherever it is. On an automotive device or the cluster, for instance, it's not unusual that the security or safety critical parts live on a different virtual machine on a hypervisor in the car, and the more relaxed security requirement UI aspects are living in a different virtual machine. And then they need to communicate with each other over gRPC, protobuf, and efficient protocols. So a lot of work happening there as well to make this distributed system architecture possible and easy in Qt as well. So it's not just UI, it's also about really system architecture. Then there is the CRA, the Cyber Resilience Act that the EU is releasing and imposing, let's say, on the software industry. It's a great opportunity, it's a great challenge, it's both sides. For us as end users, it's definitely security and cyber resilience requirements expressed in law. For us as engineers, it's a great challenge. and a great opportunity to solve some of these problems and make it still a good and productive environment. So we have been looking into the different requirements that come toward us from the Cyber Resilience Act. One of those is that we need to very clearly document what's in the box. The SBOM, the software bill of material. If you install or acquire a product that comes with a significant component, software is that, but also a device that comes with software, what is actually constituting that stack of software? What are you actually getting? So we are, of course, part of that stack, and we need to make very clearly documentation that our users can rely on, that this is what they are getting when they are using Qt in their stack. This is the risk that they are introducing by using a whole bunch of third-party libraries. Linking that back to, for instance, CVEs when they are getting raised in the relevant databases and so forth. So we are building a fair amount of software infrastructure around this right now to make sure that we have an easy, unbureaucratic way of doing that, of creating this metadata for our packages. It's super relevant for us, of course, because we are a commercial supplier of technology to our customers. I think it's also quite relevant for you in KDE to figure out how can you do that, even though you might not be directly as a project responsible for these requirements. The CRA states that the first entity that is having a commercial benefit from distributing software needs to be held liable. But yeah, I think you will have perhaps users that would appreciate if, for instance, the SBOM of KDE would be available. And I think that is an opportunity also for us to collaborate and work together with the entire industry. How can we generate this information as much as possible automatically using something that is manageable for us as developers, that we can easily work with? So if you see Alexandro at the Akademy conference this week, then he's a great guy to talk to about that. For us in Qt, of course, there is more than just third-party libraries that we need to make sure we keep track of. We also need to look at our own code and understand what is the attack vector that code might introduce to an application or to a system if there is a bug or a vulnerability. And we are focusing there right now on any part of Qt that is involved processing data that is not under the full control of the application. So anything that might constitute untrusted and therefore potentially malicious, intentionally malformed data that Qt is parsing, that Qt is processing without the application having a chance to sanitize it first, to scrub it first, whatever. That is something that we need to focus on from certain perspectives of software engineering craftsmanship, let's say. So making sure that reviewers are aware of the fact that they are now looking at a patch to code that is potentially introducing a vulnerability if there is a bug, if we have an buffer overrun or something like that. Making it possible for our CI system to focus the execution of fuzz tests or of stress tests on those parts of Qt that change or that get changed during a commit review. So there are a number of things that we can do there to integrate with tooling. But first, we need to understand what of our code is actually potentially an attack vector, and then marking that with the respective some comments. That's a discussion that we have now in the Qt project, how we do that. It's perhaps something that also then could be relevant for the KDE project to adopt. So that's something where we would very much like your input as well. And then, yeah, basic IT hygiene, I would say, governance of the account or life cycle of the accounts to the Qt project. Something where I would like to have your input. How are you doing it when people are no longer active with their perhaps approver privileged account? Yeah, at some point we should perhaps deactivate the account, remove those privileges, require a certain amount of re-authentication before we give a high degree of privileges again to users. So yeah, something that we can discuss perhaps in the hallway, how you are doing this kind of thing in your project. All right. Ecosystem and community is, of course, for us as a project, critical to think about. For us as a company, it's critical to think about in the Qt company. How can we make sure that there is an ecosystem where multiple players find it valuable to be part of, where people can contribute with their skills, with their solutions, with their knowledge, work together, build something together, make sure it's a social experience where people don't feel that they are the only ones solving that problem. So we have, of course, a very rich ecosystem of Qt solutions out there. Several thousand GitHub repositories are providing solutions for Qt developers using Qt, building Qt. In KDE, you have a rich set of frameworks that are to some degree usable also for people that are building Qt applications that are not otherwise using KDE or depending on KDE. We need to make sure that these contributors, these projects know about each other, and people that have that problem that this project is already solving can easily discover those as well. I think we haven't done a very good job with this in the past. We haven't tried very hard. So that is one of the things where we are focusing on right now within the Qt project and within the Qt company, trying to build these networks, understanding who are you, how can we find you, how can people find you. So one big aspect to that is, again, resonating very nicely, I think, with the KDE goal that was announced today about recruiting more contributors into the KDE project, also by reaching out to the educational domain, to the educational network, building networks with schools, with universities to make sure that the skills that we are looking for, that you are looking for, are actually trained and are educated and are taught in schools. So building this network, C++, Qt on the curriculum, using KDE as a project where people can start learning how to build complex software systems, I think that's going to be a very good collaboration if we can get that off. And then otherwise, yeah, building networks with projects that are using Qt today and that might be building library frameworks that many other projects or many other users are using themselves again. That's something where I would very much like your feedback and like your input as well. We have announced that for next year's Contributor Summit, we have already tried that for this year's Contributor Summit, but I hope we get a bit more momentum into that for next year's Contributor Summit, having more open source projects joining that as Qt users as well, because the perspective that we got this year from having so many people from the KDE project participating was really, really valuable, and I really enjoyed having those discussions with you. So next year we can have even more open source projects that are building technology on top of Qt and that are building technologies, other Qt projects, to become part of that discussion, share their perspectives with us, and help us building that network so that we can really make sure that the decisions we make in the Qt project ultimately are also reviewed and discussed with that perspective in mind, because I think that's very important. And we know that from the Qt 5, how many Qt users have actually waited for the KDE project to complete the Qt 6 port, which included the KDE Framework 6 port and many other things, of course. But many of our customers and many of the other users out there have looked at KDE as the lighthouse project. When KDE has finished its project, its Qt 6, then clearly Qt 6 is good enough and ready. So I'm delighted and happy that it has happened and that you have this year managed to release Plasma 6. And I think there will be many projects out there that have a similar importance for many of our users, making sure that they are also porting over to Qt 6. So, and that only can happen, and we can only support these projects if we know about them, of course. Yeah, and making software development productive and fun has, of course, been always the ambition of us in the Qt project. Giving solutions that make it easy to write software, making it fun to write software, making APIs that are hopefully intuitive to use and hard to use incorrectly, solving problems that people have. So the most important thing when we think about a tool for software developers in the end of the day is, are you getting the job done? Do you feel productive when you do the work? And are you having fun? These are the three questions. If those are not answered with a clear yes, then we need to do better in the Qt project. So that we are getting good or continue to be good at that and deliver good solutions, and that you are having fun. The feedback that I'm getting here and the vibes that I'm getting here from the conference about Qt and Qt 6 makes me feel good. That's nice. But I think we still need to continue working on that, of course, make sure that things are well designed, that things are well documented, that we are also reaching new developers with new expectations in that respect. The documentation we have is great, and it's very technically correct, and you find all the things there about the API reference. But younger developers might look at videos, might want AI co-pilot sessions and so forth to be part of that. So yeah, we need to continue working on that, of course. There are a whole bunch of things that we are working on now on the graphics and UI side. So yeah, vector animations, HDR port, hardware-accelerated 2D painting. On the graphics engine side, on the user interface side, working with what modern desktops give us as facilities for instance, transparent windows, these like effectful windows. Cute content in title bars as well, so customizing the window. That's something where I think from the Wayland perspective, we have a lot of things to work on together and already are doing that. Docking widget support in Qt Quick. And yeah, we mentioned already the unified styling architecture. On the core and non-visual side, we continue our work on the connectivity. So making it easy to consume web services, networking generally, looking also into what the C++ standard, of course, is doing with, for instance, asynchronous API, sender-receiver, and so forth. Looking into push notifications, asynchronous I/O. We don't have a good API for asynchronous I/O today in Qt. File and cloud storage on most modern platforms. You have perhaps a part of your document living on the cloud, and on macOS, for instance, that requires some certain facilities before you can access that as an application. We heard already from Ulf about things that we are planning to do for QML applications in the language. And then, yeah, a whole bunch of tooling. Fabian mentioned many of these things. Language server, for instance, making that better, integrating those into whatever IDE you want to use. So investigating what we can do with artificial intelligence technology, large language models. Can we train a large language model so that it knows what good QML looks like, for instance? Doing that in such a way that the provenance of that data is clear, that we don't harvest all sorts of open source licensed software for that purpose, but rather having a good control over that. Your experience, the knowledge that you have with QML, for instance, is also something that we can hopefully perhaps to some degree rely on in that respect. And documentation and Akademy, in this case the Qt Academy that we are having with training material, with learning material. Yeah, so yeah, hopefully the sum of all these activities are producing useful APIs for you beyond Qt 6.8 as well, and making it more productive and fun for you to work with Qt. And now I'm being shown that we have to start the question and answer session. Any questions? Question?
Okay, you mentioned in the future there's going to be a hardware accelerated 2D drawing API. Okay, can you elaborate on that?
Hardware accelerated 2D drawing API. Right now we have a scene graph API that is fairly low level for people to create something as simple as a rectangle. Well, fortunately we have a rectangle item in Qt Quick Control or in Qt Quick, and we also have the Qt Quick Shapes module that allows you to do certain things very easily. But for some, for instance, like the 2D graphs that we have, like doing an oscillogram, or some of these challenges is surprisingly hard if you have to triangulate and tessellate all your stuff manually. So having a better 2D Painter API that is more similar to what we have in QPainter, but still generates graph nodes. So there are some open source projects out there. Nano Painter, for instance, is one of those that is popular. And we are trying to see, okay, what can we learn from that? What could we adopt, or what could we use similarly to create a higher level effective or efficiently used 2D Painter API?
Okay. I don't want to monopolize time.
Any more questions from other people? Carl?
I mean, a bit related, but one of my pain points with QML and KDE widgets is that QML is super nice, but sometimes you might want to move some parts to C++ for performance reasons, for state management reasons, and then your C++ API for KDE Quick is really, really small. The API suffice. Is there some plans to maybe like include few more items to public API, like KDE Quick controls action, like some really basic, I don't want everything, but like a few more elements might be really useful.
C++ APIs for Qt Quick is something that we have fortunately avoided doing so far, because it has allowed us to change things in ways that would not have been source or binary compatible. But I think we need to start looking into, okay, what elements do we have? Can we have some more differentiated API commitments? For instance, we have now a number of APIs in Qt where we say it's not fully source compatible over multiple minor versions.
RHI, for instance, or the native interfaces. So we could do something like that also for more Qt Quick elements, but we need to be very careful and make very sure that we know that we don't plan to change things in the future, of course. Yes? Question back there.
So basically related to the previous question, what's the state of the widgets and how much effort is still going there or none at all?
Widgets are maintained and actively maintained. We have Christian Ehrlicher, for instance, from the open source community doing a significant amount of work to make sure that widgets and their styles are painting well on fractional scaling displays, that we have good high DPI support across all different platforms. So on that level, we want to keep widgets, of course, working and relevant and continuously improve them. We have made a number of improvements also to the rendering architecture on some platforms to have optimized scrolling, for instance. We have implemented a Windows 11 look and feel. Fluent Win UI 3, I think, is the official name of the design system from Microsoft. So both on the Qt Quick side, we have implemented that style now as a Qt Quick style, and also on the widget side, we have implemented a completely new style. And if you heard the previous presentation, that was a bit, or is continuing to be, some heavy lifting. But we don't right now have any significant plans to introduce, for instance, new widgets. But contributions always welcome, of course, on the widget framework as well.
So extending existing widgets with certain minor things would be accepted if they are good?
We right now we have an interesting patch, for instance, from a contributor to make the header view in our item view framework have a mode that is significantly less memory hungry. QHeader view right now creates quite large and complex data structures. If you have millions of rows, for instance, in a header view, then that costs just the header view alone already consumes a lot of memory because it needs to keep track of potential section movement and these kind of things. And we have a patch under review now to introduce a new mode where certain facilities are gone, but don't allocate a gigabyte of memory just for the header. So yes, these kind of things, absolutely interested, and contributions, like I said, welcome. They don't necessarily, perhaps that's a different discussion, releasing things on top of Qt, making things on top of discoverable also if they are not part of the Qt framework itself. If there are new widgets that people have created and that we know that people love, hopefully they can find them, but of course, again, patches to existing code or also small additions here and there, absolutely.
Somewhat similar question, again, because I think it's an important topic. So Qt widgets is not as much the focus of development anymore than it used to be. So we have that on the one side, and on the other side, we have things like Qt Quick controls, which don't really seem to be that focused on desktop applications as Qt widgets used to be. So what is your vision for how development of desktop applications, of traditional desktop applications, is going to work in the next years?
Okay. The vision for how desktop applications should be developed with Qt, ideally we get Qt Quick controls to be on parity with widgets. So like I mentioned, we have done quite a bit of work on the item views in Qt Quick to support what would perhaps consider to be a hygiene factor, but on a mobile device certainly hasn't been a priority. Flipping or reordering columns in a table. I don't know how many of you do that on a table, on a touch, on a mobile phone. But on a desktop, it's clearly something you want to do. So making these use cases definitely possible also with Qt Quick controls has been the focus. Item views, big focus on that one. Desktop styles. We took of a shortcut with Qt 6 to basically implement the quick styles for native Windows and native Mac OS by using the QStyle code from widgets and just making it widget independent. Okay, that got us somewhere, but I think it's also a very limited architecture, and it's not perfect by any means. The experience now have from Doris and Carolina here, for instance, doing the iOS style as a complete separate implementation of in Qt Quick, not using any native APIs from iOS to get the controls. I think that has taught us a lot on how we should maybe also do it for the other styles. So that's one way of also making the Qt Quick styles for desktop better. Ultimately, in the midterm and also in the long term, because widget code will be out there, and nobody should feel that they have to toss all their decades of widget code and throw it away and rewrite it in Qt because we all know what rewrites usually end up as. So rather accepting the fact that Qt and Qt widgets need to coexist and should coexist, and making that a good experience. People don't say in the end like, oh my God, I hate it, but at least I got some pixels on the screen. So making that a smooth experience and a good experience is a bit of work, both technically and architecturally, making the different composition modes work, not making it form well enough, and also flexible and toolable. That is ultimately also one big challenge with these user interfaces. People that are using the Qt widgets designer, how can we make that Qt quick aspect also a well-tooled part of it? You don't have to learn two completely different workflows. So yeah, work to be done, but I think in the foreseeable future, a desktop application that is written partially with Qt widgets and partially with Qt quick, I think is absolutely the reality, and we want to make that good.
For me it was to not just say, oh my God, I hate it, just I
paraphrased.
on Qt quick widget. We use it, we depend from it a lot in the system settings app, where some things are in QML, some things are widget. One of the most painful thing was the focus chain of keyboard navigation. So we have horrible things with event filter and things that often breaks. And so what are the plans? Are there upstream fixes?
The plan is to have it fixed in 6.8, I think.
Okay.
Doris is no longer in the room, but she spent quite a bit of time leading up to the 6.8 release with Axel, I believe, to move the whole focus chain logic into KWindow. So it's no longer, the information about focus chain no longer lives just in the widget side, and then we need to somehow merge it at runtime. So I think it will still runtime, but I think we have now a more consistent architecture, that we have a focus chain, and so that we can actually know how to pass focus through the different frameworks. If there are bugs, please let us know. I would be surprised if there are no bugs, because this is new code.
Our axe and see how it works, but I love it already.
Yeah. More questions? We have 2 more questions.
Yeah, I mean, as you might know, I was a gold champion for accessibility 2 previous years. And I wonder if there's some plans from the Qt side to improve the accessibility of Qt and Qt applications.
SVG?
Accessibility.
Accessibility.
Yeah.
Accessibility. The goal with accessibility in Qt is, of course, that it just works. We have been maybe focusing a bit too much on the plumbing and on the technology, making it possible for people to write accessible user interfaces. We have some pretty good confidence that it works, and we have at least one KDE contributor, Michael Weghorn, that is doing a significant amount of work to make sure that we support also some of the more recent additions to the accessibility frameworks, announcements, and so forth. So we have some new APIs in Qt 6.x to his contribution. But I think, yeah, in Qt we need to always be careful that, okay, we make it possible for people to write accessible applications, but is it also the default outcome of what people do? Is it a steep hill to climb to actually make an application accessible, or can we make it easy by default? So that's, yeah, there is work to be done. A diverse community helps hopefully a lot with making that better. So contributions always welcome, and very happy that Michael is doing a lot of work there for us. Okay, thank you very much.
Thank you so much. That was a really great discussion on the future of Qt. This concludes our talks for the room today. If you head outside right now at 6 o'clock in a few minutes.
I think Christian wants to talk about Qt on Python.
Wait, sorry.
Qt for Python.
Did I get that wrong? Oh. You're right. I'm so sorry. Pythonizing Qt is coming up. However, right now at 6 is the launch of the new Slimbook outside. You're also welcome to visit the booths, including Qt, Ubuntu, KDAB, OpenSUSE, and our other wonderful sponsors.
Is the clicker you were using yours?
And we'll see you in a bit.
Okay, cool. And if you have a Mac and the Mac, no, you don't have a Mac. Problem solved.
I'm just so done for the day.
Hi, Ray. We are doing. Nice to see you.
Good to see you. See you soon. Maybe Santiago, safe travels home.
Thank you. We'll hope the trains.
Have you managed to agree with Fabian?
They will. Have you managed to agree with Fabian? Okay.
Welcome to the last talk of the day, the real last talk of the day, here in room 2. After this, exactly at 6:35 is the end of the day, so that'll be fun. And right now we have Pythonizing Qt with Dr. Cristian Mariela Fredes. I hope I said that right.
Thank you very much. With the time, otherwise I will forget. Hello, yeah, so last talk, super difficult slot, but also I guess that everyone wants to go and relax a little bit after a full day of talks here. But I promise you this talk is not a technical talk, like so much technical. There will be some code there. It's mainly ideas and highlights of what we are doing with the most stable and feature-complete set of bindings for the Qt framework. I'm not being biased to saying that because that's a reality. So first, if you don't know me, my name is Cristian. I have been working at Qt company for a little bit more than 6 years now. And to show some connection to the whole community, of course, I wanted to put some, not going into full memory lane, but highlight what is my connection, at least with KDE. So the motivation that I had to be here finally in person, because in the last events I was only online, is that long time ago I was part of this community. I hope that you don't know the logo, because sadly that community doesn't exist anymore. But there was even an official blog post about it. But Elio Castro, I think that was active on the chat there. He was visiting there, the community, and then we used to have a Chilean KDE community. So this was 2010. I made a mistake of subtracting the years. I know that is a long time ago. So yeah, I mean, back then I was one of the only one pushing for Qt there around. And you might think, oh, well, there's another community there in that country. That the answer is no, because in South America, besides Brazil, everyone was the king. Everyone was doing Genome. Like everyone was doing GTK. And there were only a few weird people like this in these photos, like using Qt. I said, oh, but that thing is a European stuff, whatever. And I was like, yeah, it's so nice. So we were there doing some stuff, and I started to check this really old set of pictures, and I noticed another picture that if you were here for the initial talk this morning, that Joanna, I think was her name, that was bragging about using R Linux. I was also using R Linux there, and I also started a community. And if you are an R Linux user, you remember that. And around that time, using it was a lot of fun. But this is not the content of the talk. So first disclaimer again, like this morning's talk about Rust, the idea of this talk is not to say, hey, Python is better, Python. No, it's like, hey, Python is also there. We can use it, we can get ideas, and we can improve the whole ecosystem. So I don't want to convince you. So first of all, the language bindings in the Qt ecosystem is something that is nothing new. I mean, I will not bore you here, like explain how to do it. It's there. Nothing new, but I really believe that the bindings that we have out there are also Qt experience. And because of that reason, some people using other languages can think, oh, Qt is really bad. I will not use it, or I will not even start using KDE because of the experience that they had on those bindings. So I think that as a Qt project, we need to be responsible for it. And that's why I believe that why we need to push so much for having a good experience with Python bindings in general. So just to highlight a few that I was just checking, maybe you know that wiki page, maybe not, but only a few. We have 2 bindings for Python. We have the CSXQ that we talked this morning about it. There are other Rust bindings around. We have for Java, that is, to my surprise, Java bindings are super up-to-date and still actively maintained. Julia, Zig, Ring, you name it. There is even 26 others there. And it's super relevant. But the problem that I have is that most of these bindings usually try to put a one-on-one kind of equivalent. So you have these classes in the Qt ecosystem exposing that things in the unknown language and do it. But at some point, when we were reaching kind of like a feature completeness with the Qt framework, we thought, what about we can improve the experience of the Python users in the Qt ecosystem with our set of bindings? So. And also the idea was to at least say, okay, it's not like you can use Qt with Python, but you have other things that you can use around. So in the case of Python, I sadly need to go back to all these surveys around, like this morning we're referring, and also don't like them much. But the only thing that I want to highlight here is that even though most of us were born and raised C++ developers, we cannot neglect Python. By the way, I think that we don't even have Rust, but yeah. And I think this was shown, I think that a different one was shown this morning, was Stack Overflow survey, that even though you can see it's growing and everyone wants it, the reality is that out there, most of the developers are using technologies from JavaScript and all the others. So it's super relevant still about the thing. So, of course, most of you, just to show hands, who has never used Python in this room? Everyone's used? Perfect. So we cannot neglect this kind of things. I mean, this is only a little, I don't want you to read that, just want to see the magnitude for doing a kind of like super simple hello world in C++ and Qt, and I'm not even adding the CMake list txt there, and that will be the equivalent with Python. So even that's selling point for new users, like, oh yeah, you can do the same with this other and achieve whatever you want to achieve there for your first application, which maybe will not be a super commercial ready application, but something to get started into the Qt ecosystem, is very appealing. So even though there are some things that I don't from the current state of the project regarding syntax, I believe that is something that we need to push more so we can attract more people, and naturally we will have more people into the KDE community. So if you're not into much the history of Python, I'd say personally that Python has 3 main points where it started to shine. The first one being the whole web development thing, when you had things like Flask, Django, and lately Fast API, which is a really, really popular Python module. And then we had the second kind of like another peak of the development, which you all know, I'm almost certain, which is data science lately. And last but not least, I also believe that this is also a really cool area because there are projects like MicroPython and CircuitPython that started to brought the whole microcontrollers to the people that didn't know a lot of experience of, I don't know, memory allocations or limited RAM or whatever. So I believe that these 3 pillars of the Python community is something that is what is still making it shine. Nowadays, we know it's a reality, and you know, if someone wants to start learning how to code, you most probably will say, yeah, but you can do some Python first, and then, you know, go into the harder languages. So first, another thing that is to highlight that I guess that we cannot defeat the installing systems of Python, so pip install whatever, and then you have it. It's way simpler than at least all the other compile languages that we have there. We even managed at some point to expose, since I work in the Qt company, that kind of functionality to having private wheels, which is something that also is not very explored in companies because companies sometimes offer commercial Python packages. And we did this thing, again, it's written ++, and it was also a really good experience. At least the feedback we got from some commercial customers is really good. I was telling before about the data science popularity, and specifically on the machine learning popularity, you see those 2 are the more essential or main modules, and you can see already in the language those projects has how important C++ is. So the whole message here is that I really believe that one of the pillars of the Python ecosystem at the moment to be like such a good language is because C++. Because C++ is exposing all these, like, you know, the hardcore performance critical processes into an API, a user-facing API that is like super simple, and people without any knowledge of programming can add a few lines, train a model, and start doing things. So that's why I believe that with this combination of C++ and Python, we got the perfect recipe, right? So as I said before, we have a Python user-facing experience with a C++ core, right? I will talk about that later. But let's go about Python and Qt. So first of all, I want to clarify something that I get wrong all the time, but many people that I interact with. We have the Qt ecosystem 2 set of bindings. And I want to explain why we have 2 set of bindings. So I know that now you're expecting like all the drama behind it. It's not so, at least I was not there, but when this happens, but in a nutshell, you know, PyQt has been around for a long time. At some point, it got invited into the Qt project with the condition, of course, of changing the license. And then the people behind Qt say, like, thank you very much, but we have our own thing, we're our business around it, not convenient for us. So they say, okay, then we need to do another one. And that's why PySci was born. So maybe it was more dramatic, I don't know, I don't even want to go into the mailing list at all, but the main difference are, like this, as I mentioned before, licenses, the company that is behind the development, supports are roughly the same, and the and more part there is that I want to make emphasis why. And as I said, I know I might be biased, but this has been the goal in the latest years, that we want to offer more than just the Qt API available in Python. So I don't want to go into the details, but this is more or less the story of PySci. I joined around 2018, so you can see there, so I missed all the fun parts there before, but so far so good. We are just keeping the same release schedule as Qt, and everything is going great. As I told you before, so for Python, as I said, we would not like to just expose API, the Qt API, because then the question that all might have is like, so what's the difference? So I just change the import and that's it. And this was the state of the project at some point. And we were like really thinking, oh my God, really need to do a difference now. So what I would try to do now is to highlight which are all the features that we have added on top of just having Qt bindings for making the Python experience for new Qt developers very well. So as I said, searching for features. So the first one, we thought it was a really interesting one. It was a main use case from one of our customers. It's some code there you're unable to read so far, but don't worry, give it a couple of seconds, which is maybe you're familiarized with a solution from Autodesk. They started with this requirement that was having access to a Qt C++ application from a Python interpreter. In a nutshell, if you want to implement plugins or add-ons to the application. We thought it was the main thing that people were planning to using it. People still wanted more. So at some point we thought, what is the most popular Python model out there that we can make it interact flawlessly with Qt? And it was NumPy, numerical Python module, historical module that also was super important in the evolution and the adoption from the scientific community. And then we thought, maybe we can have some mechanisms inside to accept the data structures as they use, the NumPy arrays within that thing. And even at some point, we got a project called PyQtGraph, that I know it's at Qt, but it's compiled with PySide as well, that they asked, you know what, we really would like for QPainter to have a specific API that accepted these two NumPy arrays, whatever. And since everyone was thinking of, yeah, the PySide bindings are, there, we thought, yeah, you know what, let's break API. You have this need, it's an open source project that will benefit from it. We gave those new APIs. So this is even something that we have been open for all the other projects. Like, you need something that's not there, let's do it. We don't care. We just want to get more people happy. And the third point was Qt Creator support, at least a minimal one. So we thought that exposing a few templates there that you can start is enough. We started to work a little bit more on these things, and after you finish and selected your model you wanted to do, you can even have the option now to create your own virtual environment, which is the natural thing for Python developers to do, and then you get this nice, or maybe, I don't know, not so nice, but pop-up like, hey, PySide is not installed, maybe you can install it like that, so trying to ease the interaction there. But then I went on conference around it, and said, yeah, that's not enough. So I went, okay, let's look for more maybe Python features to this. So the first one, and this is something that you might believe maybe, that's silly, but I will tell you later why it was not. Typical nonsensical, like simple code, just to highlight that this is what we will be using in Python. And then we implemented a feature that was changing the whole Qt API at runtime to snake case. And you will say, this was, alongside the next one that I will tell you, the #1 comment that every single, it was really like a joke, like a nightmare that follows you everywhere. But you have camel case, and that feels really C++. It's not really Python-esque. So we did that, but it was not enough, because then people thought, you also need to have true properties, because in C++ we're used to setters and getters, well, in Qt, right? But in Python, that's not a thing. So we implemented another option called true property. So then you don't need all these setters and getters, and you can just directly go there and modify the property value. And as I told you, like, this was really what everyone was asking for. Even this thing as well caused like many good and positive comments in the community. Then we had QML element. So as you know, you're Qt and C++ developers, you use QML, C++ code to be used in the QML by this little macro called QML element that then at build time, because of some CMake magic, you get that exposed. We don't have build time in Python, right? So we needed to do something like, how could we solve this problem for the Python user? So we thought, what is natural for people in Python to have if you want to, I don't know, do some external decoration on things, so literally using a decorator. So then we implemented this approach of, it was literally just having one decorator on a specific Python class that needed to inherit from QObject, giving some important name and versioning, and then people would easily go to the QML there and just instantiate the object and using it all over the place. With that, also, we made a lot of QML users happy about it, and it was something that literally like changed the situation. If you were using PySide, have you ever used QML element to expose Python things to C++? Sorry, so QML? Nobody? Okay, good. So now you know, but you can do it. So yeah, this was very important, and then after that, I didn't want to put it here in the slide, but there are many other decorators that can help you, like if you want a singleton or whatsoever. So we have many methods there to do the whole type registrar thing at runtime. So every time, maybe yourself and the people behind all the support that we have in CMake gets creative with doing things in build time, we need to somehow try to figure out what we do that. As far as I know, and please correct me if I am wrong later, PyQt does not have any mechanism to do this. Tooling, then we thought, okay, maybe we need to do something about that. People don't know that we include in builds all those tools there. The ones that you see on the top, maybe you cannot read it properly, are the ones that we have wrappers around the C++ code, so the C++ tool, so we can use it in Python modules. The two there, sometimes they are super simple as calling the binary that we're including, but we also have things that doesn't exist in Qt. For example, generate type hints fun. We have even a little functionality to do a complete dump of the meta object, and even new tools that also have not getting a lot of love because we have been really bad at communicating those things, which is like you can have tools like PySide project that is kind of having a Qt creator on the terminal because you can start new projects based from templates and just build and run the application there without worrying about anything. And then you also have a tool to deploy, for example. Deployment is a big issue even nowadays for C++ and Qt developers because, in my opinion, it's not good to have the application to deploy to Linux, one to Windows, and Mac. So we thought, why reinventing the wheel, like having yet another tool-based whatever? So we started to look into the Python community, and there is recently a really good deployment tool in Python, which is called Nuitka. And it's the only one that really compiles Python code. All the other ones are freezers, the one that transforms some stuff and is a fake zip. But this is really good. Let's do just a user interface on top of that. Developer team there is super nice, super open, so we have been collaborating quite a lot. So why not? And the last that you see there on the right is the Android deployed, which I will talk about later, which was also a big milestone in our own project. So yeah, again, even with all these things, people were still asking about, what about? And, okay, let's do even more features. Android support, as I just told you. This is a case that since I joined the company, people is asking for Android support. My opinion, I'm not a mobile developer. It's really strange for someone to want to do a mobile application using Python since there are options out there that can be super simple. But again, we thought, why reinventing everything from scratch, trying to figure out everything? And one of the competitors that PySide has out there in the Python ecosystem is KWin. KWin is another framework to create user interfaces in Python. And they developed a tool that is literally to put Python modules on Android devices. And then we saw the license is compliant. We developed one tool around it that was compliant with everything they had. We contacted them. They say, hey, I have a recipe now, so you can have PySide there. So, yes, sure, let's do it. And we are reusing that thing again. So even though there are two different offers, we are trying to find our ways to interact more with other projects doing things. So if you want to know how it works, you will be unable to read here because it was recording on a screen size with the resolution too high. But in a nutshell, the first step that you maybe saw there is that just calling the Android deploy tool that we have. And we do provide ARC64 wheels, so we are using those. You can do this, the cost compilation to create those wheels for Linux or Mac. And then when we have all these wheels, we are preparing the packaging. Then you can open it, for example, in Android Studio, where you can see all the information there generated. And I think that the last step now will be that we are preparing to put the package on a mobile phone, and soonish you will see the application popping up. There it is. Oh, did I pause it? I know. So then you have the usual permissions and everything. And thanks to one of my colleagues, Shyam, that requested 2 days ago. So then you have that at the beginning. The first comment that I got when we announced Android support after all the work, yeah, what about iOS? And I was like, okay, yeah, stop. I will not even continue, even take the time for it. Another interesting experience here, which is Qt Async IO. This doesn't exist in C++, of course. And why we did it is because we had a lot of people requesting interoperability between the module Async IO in Python and PySide applications. Async.io is one of the main, if not like the maybe well-accepted modules to do asynchronous computing in Python. And there are many plugins out there. If you Google for like, I don't know, like Qt or Async.io, whatever, you will find those things. They started to stop being developed, and one after the other, they were forking each other, and then whoop, 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 and then at the end, I think there is no active project. So why not having something like that? So this was never done before because it is literally a model that doesn't exist in C++ that people import like they do with any other Qt module. So in a nutshell, you can see there like a little example that is just highlighting how do you call, I think this is the simple example that we have. How do you need to use this new wrapper around the Q application, for example, in order to make it work. So at some point, we were discussing like, oh, maybe we can make now this a C++ thing and maybe reinvent it, but no. So far, no interaction on that. And sadly, also the Adrian, the person that was in charge of the thing, at some point stopped contributing with the project. So in case you're interested with this topic, we can talk about each other. Another thing, so Design Studio. Have you ever used Design Studio, by the way, here? Is anyone using this? Okay, you are. Super requested thing by open source users and commercial users like, hey, but I want to have a Python project out of it. We didn't have support. So the solution that we have in place now that we will announce in the following days is a new option in Design Studio that then you have enabling the Python generator that will create this new Python directory inside your project where you will have a setting things that is the file that will be constantly changing in case you have more assets there in your project, and the main PY file, which in theory will not change at all. So you don't have the risk of touching again and again the files and everything. As I said, with the next Qt Design Studio release, this will be out as well, and we will be preparing a blog post about it, so you can have a look. So it's really good. And at the same time, maybe you have noticed that Design Studio also has their own Qt components that they are not in Qt. So what we also did is that now we will have a PySide Design Studio wheel that includes those components as well. So in case you just use those. Another thing that it was really interesting to achieve is that before jump from 5 to 6, we noticed that performance-wise, PySide was really slow compared to PyQt. And we did some investigation, and we noticed that back then we were using really inefficient containers in the implementation. And we improved that, and we managed to get parity of the step. But something that we are still fighting, well, hopefully for not so long, is that the loading of the modules is something that it was a little bit more slow. So this new approach that another colleague, Christian, is working, it's based on an enhanced proposal in the Python ecosystem that was rejected, but the idea was good, to improve the startup time. And I don't know if some of you were in the Contributor Summit, but we talk about that there. And for the end user, it's just fast to run a Python application. Qt Script. You remember maybe Qt Script, the one that enabled you to make some nice interaction with JavaScript that was in Qt 5 that was not maintained anymore. At some point, we had an internal hackathon, and I had the idea like, hey, maybe we can do it with Python. And everyone was like, ha, ha, ha. But it's not for real. And then we did something, and it was very interesting. The reception, at least in the company's hackathon, was, yeah, maybe we can push it later. And another colleague from the team, Friedemann, decided to say, like, hey, maybe we can do this a thing. Recently, maybe you saw that Qt Creator supports Lua now for creating extensions. And the end goal of this is to convince and work together with the Qt Creator developers to enable Python to be as a language to write plugins for Qt Creator. I don't know if you have write any like Qt Creator currently, but it's a little bit complicated. So as I told you before, the idea of this would be to embed this Python interpreter so you can use it within C++. And it was similar to the first example that I showed you there, this application, this white screen that was enlarging the fonts. And it would enable us to use these dynamical bindings for this program without relying on having this binding generator needing to be building the modules and stuff. So it will be really cool, in my opinion, and hopefully it's something that we can push soon to have this. It might be interesting, at least the people that is around this topic knows already, so I'm happy about it, is that for a long time, I remember having many conversations with people from the KDE, hey, please make it possible to build this via Flatpak. So recently, Shyam, one of the colleagues, to do enabling these things. So maybe you remember this Python with Kirigami website that is in the documentation. Before it was PyQt with Kirigami. And now we, gladly with this support, we managed to do the Python in general. So users have the choice. They can do Kirigami-based applications with either with PyQt or PySide. So this is something was recently announced there. And since about KDE, something that also makes me really happy, and thanks for Carl here, is that there's also a work being in the Google Summer Code done by Manuel, and Carl is helping him, and apparently, as I heard, everything is going well so far. So it is something that is still interesting to have. And I believe that this is kind of the idea that we need to move into the future, like stop thinking of a C++ framework and more like, like a many languages framework. So then the question was, is that enough with all the PySide features that we have? Well, I believe that it will never be enough, so we even started to think about new features. And here I want to make a parenthesis, and I want to talk about Rust. Recently, and this is my own personal opinion, some people noticed that rewriting Python code in a compiled language was faster. And then everyone was like, oh my God, right? And I was like, seriously? But anyway. This is improving the Python ecosystem, so people is happy about using it. But I really don't like when people always do this comparison about like Python being slow with compared to Rust or C++. Yeah, we know. I mean, it's a reality. This is what it happens because we don't use Python for being fast. We use Python for being convenient. But anyway, so I like the whole argument of memory safety. Yes, but if you see a person only highlighting faster, it's like makes no sense. And you might believe like, okay, well, that's a silly thing. So Rust started to be super strong in the Python community, and now there's even like companies doing tooling around it. So people decided, for example, to start rewriting different applications. The first two are rewrites of existing Python tooling, and the last one is kind of like a cargo for Python kind of thing, and they have been super successful lately. So I believe that this is really good for the Python ecosystem, and I really hope that with the CX-Execute we can manage to get into a point of having also another language and being not rewriting things like in the talk this morning was mentioning, but having new things written in Rust that can improve the KDE ecosystem. There is a different approach, though, that there's also a different company called Exaloop, decided to, you know what, Python is cool, but let's keep only the user interface and rewrite everything. One of the authors of this thing, it's a commercial-only thing so far. It's one of the people behind LLVM. So they decided to say, just using as Python as the front end, and then, well, the language that you see, and then everything else is super improved to run in different systems, whatever. And it's, I don't know, it's a nice approach that I wanted to highlight as well. So I think I still have like some time, right? So like 5. Okay, cool. So yeah, that was the parenthesis. And with regarding Rust, because maybe you have read some news or in your timeline, some respective social media like Python and Rust being really cool. And I had a talk in Lithuania where a lot of people were like, oh yeah, Rust is so fast. And I wrote one extension in Rust and one in C++, and C++ was faster. So why people is not writing things in C++? You tell me. I don't know. So the future of the project, the future of PySide. First of all, simplifying user experience. This is cute. I will give you a couple of seconds to digest the code. This is a prototype that I was playing around with because sometimes I get the complaints from people that to write a full application, they need to know a lot of things about Qt. You need to know what a Qt application is, you need to know what a Qt push button is, how to interact, and you need a Qt box layout in order to put things. And some people don't like that. I respect that. But maybe, as a Qt project, we could start envisioning trying to have solutions on top of what we have already. So this is only widget-based, and I don't think that I will ever publish it. But if you see, it's completely different, and it's super similar to other frameworks like Flutter does. There is currently something called Flet, that is Flutter for Python, that is literally this kind of like interfaces. So I don't know, maybe it's a playground thingy. It's something that is convenient for us to expose people to our dear technology, but in a way that is not so specific to our framework, and it might work. The other one is packaging and tooling. Even though we still have lots of tools, I still believe that we need to make a better work communicating it, and functionality-wise, maybe start shipping everything, but maybe have like 1 or 2 that does most of those stuff, because people get super confused. And I all the time have bug reports like, if I put Designer by a standalone, it doesn't work with the PySide plugins, and it's like, no, you need to do PySide as a Designer instead of, okay. So yeah, maybe we might work on that as well. New modules integrations. I always like to see Qt for Python as an interface, trying to get the best of both worlds. So we are still looking into other Python modules that we can have more API for, so we can use maybe, I don't know, have a Qtable widget or a view like populated by a pandas data frame, for example, if you're familiar with pandas in the Python ecosystem. Things like that might be worth exploring and might be also a good thing to have in the future. And the other thing that I was mentioning before is about this async IO module, is that maybe we will have other modules in Python only that can improve the life of Qt developers in Python. I only have a few slides, so I will be finishing soon. And as I told you before, but don't tell this anyone outside this room, if you have requested a specialized API that can break the Qt API but is solving your problem, let's talk, and maybe we can even add it to the module without any problem. If you have ideas as well, contact me. I will be around tomorrow and the day after tomorrow. Even if you have pain points, I'm happy to hear. So what's next? I think that we need to embrace the idea of a many language framework for the Qt ecosystem. I don't know, maybe because I'm getting old, but I really would like for us to be boring. And in a sense of like, do not try to reinvent a new super parser that does something. If there is something out there, let's use it. Or if they did something that worked, let's do that with every single language. Because sometimes you don't need to invent new things all the time. You can adopt and nurture whatever you have with those things. So that's the thing that I really enjoy a Qt ecosystem, imagining like everything acting together, and imagine all the possibilities that we have, like putting more languages, more ideas, more mechanisms that maybe solve problems that you as a Qt user, as a KDE user have. And then with all these things, you know what we can, we can have a better Qt ecosystem overall. And with that, I just wanted to see, like, again, if we have a better and polyglot Qt framework, that means a better KDE for sure. So yeah, thank you very much. And if you have maybe any question, you can let me know.
Questions?
And if you don't have it, you can catch me out as well. Thank you.
That was great. That was very, very, very good presentation. Thank you so much.
Thank you.
So this does now actually conclude the day in this room. My brain checked out an hour ago already, but here we are. So that's it. See people tomorrow. On your way out, make sure you grab your t-shirt if you ordered it up from the front info desk. And yeah, we'll be here tomorrow morning. Always looking for volunteers, by the way. And have a wonderful evening.